The search for extraterrestrial intelligence is an exercise in difficulty. It's tempting to say that after decades of searching, since Frank Drake's Project Ozma in 1960 to now, that since we've never seen any signals that we can unambiguously state are of alien technological origin, they just must not be out there. But the reality is that the signals we search for today are going to necessarily be subtle and difficult to pick up. Not impossible, but we've also only barely searched these with targeted SETI radio telescope searches. But it's not just a matter of pointing a radio telescope at as many star systems as you can. There are as many as 200 billion of them in this galaxy alone. That's a lot of searching. But you also have to keep checking them across time. When you don't know what aliens transmit, or what frequency they transmit at, or when they repeat, you've got a lot of work ahead. Most of which is yet to be done. What we do know reasonably, though, is that the original idea of a huge beacon blasting out radio energy as a contact signal seems to not be happening in the galaxy. We had to look, but the beacons of the original Kokoni and Morrison paper that set SETI in motion were probably always a long shot for anything but a super civilization due to the energy requirements involved. And there has also been the progression of technology. The big ear radio telescope that detected the famous and still unexplained WOW signal had a receiver that only had 50 channels, near 1420 MHz, each being a slice of only 10 kHz wide over such a tiny area of the radio spectrum. It really was a very tiny area based around the hydrogen line idea that putting a signal near where neutral hydrogen emits radio is a natural signpost, a place for a contact signal. Since all scientists doing radio astronomy in the galaxy know about that 1420 MHz area. But the reality is that aliens could be transmitting at any frequency, especially if those transmissions are their internal communications, not intended to say hello to us, that we happen to be able to eavesdrop on. As a result, SETI receivers now cover millions of channels in large areas of the radio spectrum. We are much better at picking up signals than at any other time. But here too is a problem. That creates a huge amount of data, and that data must be sifted through. In the past, the SETI at Home project used the resources of the public participants' computers as a screensaver to crunch the data. That no longer exists. But this task of data sifting continues now with computer programs that automatically sift the data and pick out signals of interest, which the scientists then follow up on. One of the major programs used is known as TurboSETI. This is a standard algorithm and does not employ machine learning. You basically tell it what human interference looks like and it carries out its instructions as to filtering it out. It works, but it's not perfect, and signals of interest do get missed. Yet it produces a lot of signals that are of interest initially, but most of them being due to interference it wasn't familiar with. Humans then had to go in and improve the program. This is still a problem in SETI. One of the more noteworthy candidates in recent years was BLC-1, which was a strong candidate signal, but ultimately proven to be interference no one had seen before. But in any case, the data sifting can't be done manually. Nature produces all sorts of radio signals, and human interference from our own transmissions is an ever-present problem. There can initially be tens of thousands of signals or more, so each signal in a typical SETI experiment dataset never gets looked at by a human, and thus gets filtered out by a computer program designed to spot and eliminate those signals. And with that, there is the risk that a signal of alien origin could be missed. This is complicated stuff because there are differences in how these programs are written depending on a number of variables, and indeed the type of radio telescope used to collect the data. There is a difference between a single-dish radio telescope and an array telescopes and how the data is processed. But work is proceeding, and a new way of filtering signals using machine learning has both shown promise and indeed has yielded 8 new signals of interest that were missed in previous searches of that particular data set. In a paper by Peter Ma and colleagues, link in the description below, they detail a new way of searching SETI datasets employing machine learning. The dataset they searched was about 480 hours of data taken by the Green Bank Radio Telescope in West Virginia, taken as part of the privately funded Breakthrough Listen initiative. This comprised 810 nearby star systems. The new program broke the data down into snippets and searched them for signals of interest. it found millions, but rated them on how confident it was on them actually being an interesting signal. It then learned from that and organically learned how to filter signals. As a result, the team was able to throw out 90% of the signals as probable Earth interference or natural phenomena, and they avoided areas of the spectrum, which ran between 1 and 2 gigahertz, that were known to have heavy Earth radio traffic. That process still left over 20,000 signals to do a second check on. But what was of note is that the result was actually less than what a program like TurboSeti would have produced. This means that the new program is better at removing false positives. And that's where this gets interesting. Even though it's a more reliable program, it still produced 8 signals of interest after all was said and done. And these signals had not been caught by previous searches of that particular dataset. And here's the kicker. While there were 8 signals, they came from only 5 nearby stars, meaning that 3 of the targets actually produced 2 signals of interest, albeit at different frequencies. Because of the difference in frequency, they were treated as separate detections, but it's difficult to ignore 2 signals on 2 different areas of the dial coming from the same star system. These star systems are very close, ranging between 30 and 90 light years away, which incidentally lies within the zone of Earth's broadcasting time where aliens could see our signals, but partly outside of the time needed to send a signal back to us. The signals passed 2 tests. 1, they were narrowband. Nature only rarely and very specifically produces narrowband signals, instead bleeding and smearing broadband all across the dial. Technology, on the other hand, prefers narrowband, because the more broadband you go, the more energy you waste, and the more you bleed into other useful frequencies. But that's a problem for SETI, because the vast majority of our signals, the interference, is narrowband. But it's only step 1. The second is the Doppler effect on the signals. This is the Doppler shifting of the signals if the source is moving, such as if they originate on a planet or station orbiting a star and constantly moving in its orbit, or on a planet constantly rotating on its axis. These signals exhibited that, and they did it in a different way than the more famous recent BLC-1 signal, which has shown to almost certainly have been human interference, though it's not clear exactly what was producing it. Some comparisons between these new signals and BLC-1 have been made, but they aren't that similar. BLC-1 had the tricky problem of coming from the direction of Proxima Centauri, the nearest star system, which creates a statistical problem. If you detect an alien signal from the next star system over, then it implies that alien civilizations or colonies of a civilization pervade the Milky Way and are everywhere. Thus, you should expect to be detecting more signals of a similar nature everywhere, and we simply aren't. These new candidates suffer less from this problem being distributed further away. The other issue is that BLC-1's drift was weird, in that it was the opposite of what you'd expect from an alien signal. Not so with the new candidates. But as is the age-old problem with SETI candidate signals, follow-up observations failed to pick up any of them again, though the authors urge further follow-ups to get a longer sampling of observations of these candidates. Until they repeat, however, they are wow signals, and simply aren't actionable evidence to determine if they are truly alien. And we don't know everything, nature surprises. And signals like this might signal some previously unknown astrophysical phenomenon, though the narrowband nature makes this unlikely. And then there is Earth interference, and that's beyond extensive, and as BLC-1 showed, can confound SETI search algorithms and mimic signals of interest. Repeated detections are needed to eliminate that issue. The good news is that this new data mining approach for searching SETI databases has no shortage of them to look through. There are more sets from Green Bank, but there are also the Parkes Radio Observatory, and also with more development, datasets from the multiple telescope arrays. But it's interesting to compare how we do SETI today versus how it was done in the past. There was never really a time where a radio astronomer equivalent of Jodie Foster sat around on top of a car listening to radio hoping for prime numbers pulsing in the earphones. But there was a time, such as the WOW signal, where the data had to be visually searched, in this case by volunteer Dr. Jerry Eman, during his off hours while as a professor at The Ohio State University. For those interested, in the early days of hosting Event Horizon, we sought out and interviewed Dr. Eman. An interview that gave me chills when I did it, due to the perplexing nature of that signal that haunts me to this day. link in the description below. But these days, SETI searches aren't really conducted by humans any longer, but by computers. The computers report back to us what they find or what they don't find. This leads to a curious situation. As human technology advances, we end up doing less and less ourselves, leaving it to labor-saving devices such as computers. In communications, computers run a lot of the infrastructure, such as satellites. Might it be that this trend continues for any technological civilization, and that our first contact with an alien civilization won't be us talking to aliens, but a machine talking to a machine? Thanks for listening. I am futurist and science fiction author John Michael Godier, currently eyeing the radio telescopes suspiciously. Hidden signals that you have to dig deeper into in order to uncover. A likely story. And be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular, in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live. Regardless of what one may think as far as solutions to the Fermi paradox and just how common life is in the universe, one thing is clear: we exist. That we do clearly shows it's possible for intelligent life to exist in the universe. So the question remains, how common is other life in the universe, and can we find it? In this regard, much is made of the idea of the Great Filter. Some event or circumstance develops that makes intelligent life very rare. Some of these proposed filters lie in our past, and that we only got past them simply by chance. Some of them may lie in the future, and that some event that will lead to our extinction lies in our, and indeed anyone else's, future. But you can flip this around and ask if there are factors that might change the equation and make alien life more common than we might have imagined. So here are 10 anti-great filters that may make alien life, and perhaps intelligence, more common than we might have thought. Number 10. Who says it can't happen another way? A lot of how we speculate about alien civilizations tends to be based on one very important reality, but it can also lead to bias. It's simply that we have only a sampling of one regarding technological civilizations, our own, and from that, we ask questions such as how suitable an exoplanet might be to life based on the criteria that led Earth to be habitable. Examples of this include the existence of our moon creating tides that might have made tidal pools potentially necessary for life to arise. There is also the generally calm characteristics of the sun, the presence of Jupiter to clear out dangerous material from the inner solar system, and so on. This is reasonable to a point, since we know a fair amount about how life arose on this planet, the conditions that allowed it, and how it led to us. But it could also blind us to ways that intelligence might come to be on an exoplanet that might have went through a very different set of circumstances to get where it is. We only know what happened here, and as complex of a set of circumstances as it was that led to us, an equally complex set of circumstances very different from our own might have led some alien civilization to intelligence in a way that we simply haven't thought of. This has happened a lot in the history of science, where you don't actually know what's possible until you actually see it. In fact, there is a tendency to doubt it outright if anyone suggests that something might be possible, only to later find out that nature had already done it. Number 9. Time conquers all. We don't just live in a universe of space, it's also a universe of time. The universe is well old enough to have produced civilizations that are millions or even billions of years older than we are, whether they are extinct or still alive. And for most of the life of the universe, it lies ahead of us. We could literally someday be someone else's ancient, extinct necrosignature that tells them that there was once life on this world. But there is also the idea that we may be early in the game, and among the first civilizations to arise, and that in the future many more will come, leading to a blossoming of intelligence when the universe becomes truly ancient. In general, more chances for life to arise and become intelligent lie in the future as opposed to the past. Number 8. We don't know what an advanced alien civilization looks like. Life in the universe is difficult to detect. For the biosignatures, there are currently only a handful that we might use to try to find alien biology itself. But it's tricky, to say the least, because it's certainly possible to have a planet with a biosphere that is simply indetectable at a distance, especially if the biology of that life is significantly different from Earth. Now, we have only just begun to think about searching exoplanets for biosignatures, and it's possible that we might find examples right off the bat, and know that the universe teems with at least plant analogs. But if we don't, it's not a deal breaker for the existence of life. It's simply that we have no way to see it. Civilizations, however, seem to be a bit different of a story. We can try to envision them with giant megastructures or radio signals detectable across light years, but there's also just as much of a chance that alien intelligence might be far more subtle. After all, if anyone looking at this world further than just over about 100 light years, human civilization would have been undetectable on this world, though evidence of life itself would be. A good example of this would be a machine civilization. We don't really know what that would look like. Instead of a giant supercomputer Dyson sphere, it may simply look like a wispy cloud of nanotechnology. Or it might be very low-key, using only the energy it needs for computation and ignoring the rest of the universe. Or a civilization of this type might even try to hide itself. Better to just do your own thing and not interact with others. The point is, we very easily may miss an advanced alien civilization, just as easily perhaps as detecting one. Number 7. Better than Earth. We often think of Earth as perfect, a jewel of a world that is so clement that even very delicate life can arise and exist on its surface. But this may be a bias, and that Earth as a water world may actually be less than ideal for life to arise. Yet, it's clearly possible, so here we are. And the idea goes on to say that perhaps there are better planets in the universe for life to arise, and perhaps evolve to become intelligent. One aspect here is Earth's size. One contributing factor for Earth's habitability is plate tectonics, which drive the carbon cycle. When a planet's plate tectonics stop, or are never present, life is disfavored. But what of a planet with more plate tectonics than Earth? There seems to be a sweet spot here favoring plate tectonics at about 1.3 times the radius of Earth, and about 2 Earth masses. It's also worth noting that Earth lies near the inner edge of the Sun's habitable zone. Planets a bit larger than Earth, but not too large, sitting in the center of their star's habitable zone with slightly thicker atmospheres and stronger magnetospheres, might fare better than Earth in this regard in certain circumstances, such as a planet with multiple moons. Other possibilities include a planet's distribution of land, which might be more ideal than Earth, or even more oxygen, but not too much, that might allow for bigger life and bigger brains. In short, it may be that while Earth is utilitarian and can support life, there may be terrestrial worlds out there that are supercars in comparison to our aging LeBaron, and may host much more diverse biospheres and intelligent life. Number 6. Sheer numbers. Vast is not really a strong enough term to describe the universe. We live in a galaxy that contains as many as 200 billion stars, a great many of them possibly capable of supporting life. More, it's thought there are 125 billion galaxies in the observable universe, all containing enormous amounts of stars. Beyond the observable universe, we simply don't know how many more stars there are. Because of this mind-boggling amount of stars, some just like the Sun, it becomes almost a certainty that we are not alone. Earth almost cannot be the only lottery winner in the universe, but this doesn't mean that we will ever know if anyone else is out there. Distance and time play a role here. When we look at distant galaxies, we see them not as they are, but as they once were, and often from a time where raw materials and conditions for life and habitability simply did not exist yet. And the more distant a galaxy is, the harder it is to search for life within it. In most cases of bio or technosignatures, we are limited to our own galaxy, and indeed this tends to generally be the close parts. But even if we can't ever answer the "are we alone" question, we can still reasonably say odds are someone else is out there. Number 5. The sharpest knife in a drawer full of razors. As far as life itself, we don't know very much about the conditions in which it arises, merely that it arose very rapidly on Earth for some reason, but it can also be destroyed and go extinct, meaning that life might sputter early in the history of a habitable planet. It might arise, get hit with an asteroid, and arise separately again at some point if the conditions are right. This also leads to a curiosity of intelligence. There seems to be different paths to it. Some of the birds, for example, are highly intelligent and even seem to understand tool use. This leads to the open question of how intelligent their dinosaur ancestors were. Had that asteroid not hit and caused the extinction of so much of the dinosaur line, might they have achieved human-level civilization millions of years ago? And the question can be asked about more recent history. There have been multiple species of human before us, all highly intelligent. This at a time where the dolphins seem to be moving towards intelligence themselves. And then there are wildcards, like the cephalopods. This planet seems to be producing multiple intelligent species, and hominids just happen to be the first lucky group that didn't get derailed by one factor or another. What lies in store for the future of this world as far as the evolution of an intelligence? And, more importantly, what might be happening out in space? Number 4. Life on Earth arose very rapidly. One sort of glaring thing about life on Earth is that it seems to have arisen literally at the very first moment it could, and indeed seems to have done it when the conditions were not ideal, and possibly even into the late heavy bombardment if the dating of some evidence is to be believed. This carries with it a very strong suggestion that can be interpreted in several ways. The first suggestion is that life on Earth was deposited here through panspermia and originated elsewhere, possibly Mars. This is because it's thought that in some ways Mars might actually have been more habitable than Earth in those days. And with so much bombardment going on, exchanging rocks between terrestrial planets going on regularly, the planets were literally sneezing on each other. The other possibility to explain the genesis of life is that it's actually pretty easy for nature to pull it off. It's an inevitability, perhaps, of organic chemistry under the right circumstances. In this case, we don't know all the rules, but someday we will, and out of a test tube, so to speak, a second genesis of life on Earth will come from a laboratory. When that happens, what will we define it as? Does the term artificial life enter the lexicon of human languages? And if it does, can we call it alien life? How blurred will the lines become? Let me know in the comments below. Number 3. Uplifting. While it could be the case that intelligent life in the universe is very rare, we ourselves prove that it is possible. This could mean that you would have to search galaxy after galaxy to eventually find another civilization, and even then it may be long extinct. But what of an ancient civilization that was not extinct, or human civilization several million years from now? What might they do with their galaxy? One answer is that they might settle it, and if they did, the scenarios possible for how life exists in that galaxy start to stretch the imagination. Say they settled all habitable worlds. Would their evolution and cultures change so much over time that even though they are related, they might not even know it, creating a galaxy full of de facto alien worlds? Or what if finding inhabited worlds without intelligence and then uplifting life there to be intelligent? In other words, create your own alien civilization. Or say things like 3D printing out custom intelligent species comes onto the table, which in such a case, the word alien itself becomes blurred again. The point is, you may only need intelligent life to happen once in a galaxy in order to eventually produce an enormously diverse variety of life all over a galaxy spread by technology. What would such a human-dominated galaxy look like? Number 2. Panspermia. As I said, the idea of panspermia essentially boils down to the reality that planets sneeze. They undergo impact events that can lift rocks off their surface that may harbor microbes and under the right conditions can transfer them to other worlds where they might get a foothold. This opens up a whole new class of unknowns as far as life in the universe is concerned. Take for example red dwarfs, by far the most common type of star in the universe and a very, very long-lived, stable type of star. These have recently been thought to generally be bad for life to arise around. They are very active flare stars when they are young, with their Earth-like habitable worlds being located very close in and getting their atmospheres ripped off. But this leaves out things like ice shell planets and moons that may host aquatic environments where life could arise and remain protected from the red dwarf, or even specialty worlds where the local circumstances might allow it to arise. But there's also panspermia. In a situation where life is constantly being exchanged on worlds, Who is to say what's possible? Can an ancient star system, long quieted down, become reinfected with life through panspermia? Number 1. Type K orange dwarfs. One big question regarding life in the universe is that the sun seems, well, in some ways imperfect for fostering life in its habitable zone. The main argument here is that the sun is on its way out, loosely, as far as supporting life on Earth. While yes, it drove and powered life's evolution that led to us, and may well produce more intelligence should we go extinct, it's still increasing in luminosity, and will eventually bake the surface of this world. In only about 600 million years, the plants will start to become unviable, and with that, animal life. The microbes will still rule the Earth for a bit longer, but at some point, they too will go. So the question is, are there better, more long-lived stars for life to hold on around? The answer is that it's situational. Frozen worlds might become viable for microbial life later in the lifetimes of stars, and some stars, such as red dwarfs, can live much, much longer lives of stability than the sun. But they don't seem all that habitable to life due to their habitable zones being located much closer in. But there is a type of star that might be just right, the type K orange dwarf, which is much longer lived than the sun, but sports a habitable zone much further out than a red dwarf. In the case of those stars, life gets an extension of many billions of years. So who knows what life might do around such very common stars, more common indeed than the sun. Thanks for listening. I'm futurist and science fiction author John Michael Godier, currently worried about our standing amongst the aliens. So if we ever send out a METI signal to try to actively contact aliens, what happens if they're like, oh nice, a signal from a new intelligent... Oh, look at that planet. We need to send them some mass. Very disturbing. And be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations of the interesting, weird, and unknown aspects of this amazing universe in which we live. On this channel, a common theme is coverage of astronomical objects that should not behave as they do. These include the usual suspects, such as Jabilski's star and the transuranic elements apparently in it, and the mysteriously dipping star KIC 8462852. But there are a number of such objects that I've never covered or only briefly touched on, and a few that are new discoveries. So here are 10 astronomical objects that are not behaving as they should. Number 10. The galaxy with not enough dark matter. One of the great mysteries of science right now is what the nature of dark matter could be. Our understanding of dark matter, murky though it is, comes largely from the behavior of galaxies. Without the presence of dark matter, they would fly apart. Therefore, there must be something that interacts with normal matter gravitationally, but we can't see it and haven't detected it. Then it must not interact in any other way. The nature of dark matter is a complete unknown, but the general view of late is that it's likely to be in the form of an unknown particle known as a WIMP, or weakly interacting massive particle. There is also an opposing point of view that says rather than invoking invisible matter, shouldn't we first try to determine if there's something wrong with our models of how gravity behaves at long distances? And then came the galaxy NGC 1052-DF2. This galaxy is ultra-diffuse, and on its face it appears to have very little dark matter. As is usual, the galaxy was re-examined and a number of papers came out questioning the distance to the galaxy, and reconciling that it actually did have the normal amount of dark matter. Then another galaxy like it was found, complicating the issue, and painting a picture of these types of galaxies that seem to not contain dark matter as not particularly rare in the universe. So the matter remains unresolved. However, if it is determined that these types of galaxies are in fact devoid of dark matter, then it casts a shadow on both points of view, whether the discrepancy in our understanding of gravity or the existence of weakly interacting particles, they both should be universal and seen in all galaxies. If that's not the case, then it's back to the drawing board as to explaining just what dark matter is. Number 9. The intermittent white dwarf. We often refer to white dwarfs as dead stars. glowing cinders of stars radiating their remaining heat until eventually they are predicted to go black. But there's more to that story. Sometimes white dwarfs in binary systems can accrete material from their companion star, not entirely unlike the accretion disk of a black hole. This causes white dwarfs to brighten as material is drawn in from the other star and act as sort of zombie stars. A few days ago, however, a team at Durham University in the UK announced that they found a white dwarf that suddenly switched off. The system in question is TW Pictoris, and consists of a white dwarf feeding off of another star. Normally this situation is called a cataclysmic variable, where the accreting material can cause the white dwarf to brighten. This also used to be called a nova, but it's complicated in that certain cases can actually cause a class of supernova that destroys the white dwarf involved, exploding zombie stars. But with TW Pictoris, its rises and falls in brightness are on very short timescales, not seen with any other white dwarf so far. It can rise and fall dramatically in brightness over the course of just 30 minutes. The working hypothesis of why this is has to do with the white dwarf's magnetic field, interrupting the flow of material from the accretion disk that happens to be on very short timescales. But more of these types of situations should be seen, and probably will be, but so far, nothing yet. Number 8. The Green Star. Humans have looked at the stars since the very beginning. The very first creature that could be called human almost certainly looked up at the night sky and wondered what the points of light were. It may have even formed, or inherited, a mythology regarding the stars and planets overhead, something that is common to just about every group of humans that have ever existed. Indeed, what might be the oldest myth preserved in humanity deals with the Pleiades, and concerns multiple identical stories about a seventh star in that system, the Seven Sisters being chased by variations on the constellation of Orion, when you only actually see 6 stars with normal human vision. This story ranges from ancient Greece to the Middle East, to very distant and then isolated Australian Aboriginal cultures, separated from parts of humanity having the same story for as much as 50,000 years. This implies a story that has been passed down in many traditions since they last had contact. As a result, this story could be as much as 100,000 years old, and that seventh star, which is no longer visible to the normal naked eye, exists. It's just not visible to modern humans. This interest in the night sky also gives us a long record of human observations of the heavens from multiple different sources dotted across Earth, allowing us to look for things like past supernovas in the historic record. But this has also led to discrepancies, where ancient accounts of the night sky don't actually match what we see today. One example of this is the star Beta Librae. There are actually 2 discrepancies with this star in the historical records. The first concerns its brightness. Eratosthenes noted that this star was brighter than Antares, yet 3 centuries later, Ptolemy said it was as bright as Antares. If these observations are correct, and remember they were both visual made by ancient Greeks, then something changed. It's uncertain what, but it could be that Antares has brightened, or Beta Librae is a very long period variable star. The second discrepancy is in the star's color. An inordinate amount of historical observers have called this star green. It's not, it's a blue-white star, and a green appearance is due to the human eye when looking at dim objects, and actual green-colored stars do not exist in nature. Those stars do emit green light. But this star does not appear greenish today to any observer, so it remains a mystery as to why people in the past saw it as greenish. Number 7. The Tired Pulsar. Pulsars are usually very regular things, operating like clockwork so precisely that you could almost use them to set a clock to a precision rivaling an atomic clock. But for reasons largely not understood, they can simply stop pulsing for a time. This is known as nulling, and the pulsars that do it tend to only stop pulsing on a timescale of a few pulse periods to a few days. This is thought to be due to one of 2 things. Either there is some intrinsic issue going on with the star itself, such as something related to a starquake perhaps. This is known to probably cause what's known as glitching in pulsars, and results when the pulsar's crust cracks and moves, disrupting everything including its magnetic field. Or it could be due to something going on with the pulsar's magnetosphere itself. Either way though, those effects should be relatively transient. But there are two pulsars that don't quite fit here, and it's very unclear why. The first is a pulsar known as PSR B1931 plus 24, where you see the pulsar for about a week, then it stops for a month, and then it turns back on for a week in a regular cycle. It could be that under certain conditions a pulsar can change the direction of its beam and we no longer see it, and then return in some kind of cycle that's going on in its magnetosphere. But this appears to be a rare type of pulsar working on a mechanism we don't understand. But as usual on this channel, there's a worse one. The pulsar PSR J1841-0500 is a very distant pulsar at over 22,000 light-years away. This pulsar was discovered in 2008 and seemed to be normal, pulsing regularly every 0.9 seconds. But in 2009, it stopped completely. After a few days, it still wasn't there. After a few months, it was still not there. This pulsar was silent for 580 days before it abruptly started pulsing again in August of 2011. So far, no other pulsar like this has been found, and exactly what happened there is unknown. Number 6. A star within a star. Within theoretical astrophysics, there is an object known as a Thorne-Zeitkow object. I covered this concept on this channel before, so I won't go into detail, but essentially it's a situation where a neutron star and a red giant merge, leading to a stable situation where the neutron star exists at the core of the red giant, making for two stars in one. But that idea was only ever hypothetical, but it was testable and made chemical predictions. These predictions included abnormally high levels of certain elements, coupled with high luminosity. This, in principle, should be detectable in the star's spectrum, so searches have been made. The first candidate for such an object was HV2112, which showed overabundances of lithium, calcium, molybdenum, rubidium, and others, which would have been consistent with one of these objects. This was called into question, however, by another team that argued that only lithium seemed elevated. But another candidate has shown up, known as HV11417, that seems to have too much rubidium and a high luminosity, making it a somewhat strong candidate for a Thorne-Zeitkow star within a star. Number 5. The oldest black hole in the universe. The quasar ULAS J1342 plus 0928 is the second most distant quasar known. Within this highly active galaxy, astronomers have found a supermassive black hole, weighing about 800 million times the mass of the Sun. While there are supermassive black holes far more massive than that, the size of this black hole presents a mystery. The reason is that this particular black hole is so distant that it's the oldest black hole we know of, dating to have formed only about 690 million years after the Big Bang. This is interesting, because when that light left this quasar, the universe was in a bit of a different state than it is right now. This is known as the epoch of reionization, and quasars may be key to understanding how this reionization occurred, making quasars that distant important objects of study. But by being such an early object, this black hole intuitively shouldn't be as massive as it is, yet it exists, presenting a challenge to current models of black hole formation. Number 4. Our solar system. Why haven't we found another? One thing we've noticed recently as we've studied exoplanets is that so far, no other star system we've seen looks quite like this one. For example, an entire common class of exoplanet known as super-Earths is unknown here. The solar system has no super-Earth. The list goes on. This solar system has no hot Jupiters, brown dwarfs, and where our star system really stands out is that it has an inhabited planet with a civilization living on it. This may indicate that there's something we don't know about planet formation, and that our solar system formed under unusual conditions. This has an unusual implication in that it could mean that Earths are rare, and only form under the conditions of a special type of protoplanetary disk. It would not be unique, merely rare. The interesting thing about this is that we're actively studying exoplanet systems, and new ones are identified all the time. As we characterize our ever-growing sample, it should become apparent whether the solar system truly is a rare configuration, or if it has analogs in the local neighborhood of stars. Number 3. Strange radio waves from the center of the galaxy. As radio astronomy has progressed in recent years, a number of new unexplained signals have cropped up. This is especially the case near the center of the galaxy, where a number of transient radio signals have been detected, forming several new classes of unknown object. Known as galactic center radio transients, there are several of these phenomena, but one in particular is quite recently identified. Known as ASCAP J173608.2-321635, this new object is thought to be related to the GCRTs, but it isn't exactly like other known examples. This radio source initially came in as a polarized signal, meaning that its waves oscillate in only one direction, but over time, the whole thing rotated. Also, the signal varied in strength, and finally, it intermittently disappears, only to come back. This signal doesn't really match other known astrophysical phenomena, but it also doesn't look artificial, so this probably represents some new astrophysical phenomenon we haven't seen yet, that is dependent perhaps on the conditions present in the cramped center of the galaxy. Number 2. The infrared laser star. MWC 349 is a double star, made up of a giant star and a supergiant star orbiting each other. Due to some unusual properties associated with this system, it's possible that there is a third star in the system. What's going on here isn't entirely clear, but one of the stars seems to have a high mass loss rate, and it doesn't neatly fit into any normal star categories. There is also a disk of material in the system that doesn't appear to have originated from the star, so it may be that this is a very young star system, recently ejected from a nearby nebula. But the strangest aspect of this star is that the debris disk seems to be generating infrared laser and maser light. It seems that some configuration of the dust and gas is organizing the light. This is not unheard of. There is one other example of a star emitting laser light, but it's doing it in ultraviolet. How an infrared laser is being generated here is a mystery. Number 1. The new mystery. Recently, a new addition to the list of strangely dipping stars was added. This is the binary star system TIC 400799224, located about 2,300 light-years from Earth. This is a discovery by the TESS satellite, which looks for exoplanets through the transit method, and is a successor to the Kepler mission that found KSE 8462852. Once every 19.8 days, something passes in front of the star blocking starlight. That's a very short period, so in each successive pass you'd expect it to appear roughly the same. That is not the case. Whatever's blocking the starlight varies wildly, in both depth of dip, which ranges from a few percent to 25% so far, and over varying periods of time up to several days. There have also been observations that when a dip was expected, nothing happened, and no material seems to have passed in front of the star. This rules out a lot of things. Planets don't change repeatedly over the course of 19.8 days, but normal dust clouds don't either. So whatever is happening is emitting dust. The dust cloud drastically changes shape before being blown out of the system by the star's solar wind. To account for this requires a massive amount of dust being created. Even large asteroids losing dust somehow wouldn't last long on astronomical scales. So the best current working hypothesis is that it's two objects, giant asteroids perhaps, repeatedly smashing into each other and intermittently generating dust. But this may not cover all aspects of what's being observed, so for now, it remains an unknown. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently taking a break from spooky October scripts. But just wait, they've been spooky so far, but now we move to the terrifying, and be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live. Stars are usually but not always straightforward objects of nuclear fusion that can be predicted as to their general behavior, type, how long they will live, how they will end, and so on. But as with a great many things in this universe, there are gray areas where types of stars very different from the stars we normally see can exist, or may have once existed, or will exist in the very far future. So here are 10 bizarre but possible exotic stars. Number 10. Quasi-stars. Fundamentally, the Big Bang produced 3 stable elements in nature, hydrogen and helium, and a very small amount of lithium, that left the universe with a very pure chemical mix. This lack of contamination by later elements formed in the earliest stars leads to the possibility of a very odd object that may have once existed, but is no longer likely to form in the universe. Known as a quasi-star, this object would have formed when a protostar in the early universe collapsed into a black hole. Instead of the normal supernova that we would see today, the outer layers of these hypothetical, extremely massive stars might not have been blown off, but rather may have been retained, forming a very luminous giant star with a black hole operating in its center, giving the energy to the star as a whole as opposed to nuclear core fusion. In fact, it would be so luminous it would outshine the entire output of a small galaxy today. Best thought of as superstars, these stars would have been truly giant, over 1,000 times the mass of the Sun, and may have even been helped along by their equally gigantic dark matter halos, drawing in ever more gas during formation, leading to the possibility of quasi-stars of tens of thousands of solar masses. Instead of how stars normally work, with equilibrium being held by the outflow of energy from the core, this would be achieved by the outflow of energy from the black hole gobbling up material. But these objects would have been short-lived, on the order of only a few million years before cooling to a point that its outer layers would become transparent, and then dissipate, leaving behind a normal black hole. Number 9. Quark stars. One of the stranger types of objects in the universe that we know unequivocally exist are neutron stars. Neutron stars are collapsed stars that have gravitational fields so strong that matter is crushed down to neutrons. But these stars are not massive enough to collapse completely to become black holes, but there may be an intermediate state. At just the right pressures just above what would form a normal neutron star, it may be possible to collapse the neutrons down to their constituent quarks. This would result in a star made up partially or entirely of exotic quark matter. It has never been shown that quark stars actually exist, but that may simply be due to them appearing like normal neutron stars. But it may also be that they are simply rare or otherwise difficult or impossible to detect at a distance, but may have properties different from neutron stars, in that they may be radio silent or have differences in their magnetic fields. There are, however, candidates that have been found in the form of seemingly overdense neutron stars, but whether they are indeed quark stars is debated. Number 8. Q stars. Pushing even closer towards collapse into a black hole, there is the concept of a Q star, or sometimes called a gray hole. These hypothetical heavy neutron stars would be similar to quark stars, also containing some type of exotic matter, but they would be so massive that unlike a black hole where no light escapes, some light would escape from a Q star, but not all of it. It's possible that we may never be able to detect these objects at a distance if they exist, because it would be very difficult to differentiate them from stellar mass black holes. Number 7. Blue and black dwarfs and iron stars. Like the early universe, the far future universe offers possibilities for types of stars that currently do not or cannot exist yet. This is because this group of stars requires an immense amount of time to form, far longer than the current age of the universe. And indeed, one of these is the ultimate fate of our own sun. The first is the blue dwarf. This type of future star comes at the end of a red dwarf's lifetime, which is incredibly immense, so we won't see these kinds of stars for trillions of years at least. Then there is the black dwarf, which is the end stage after a white dwarf cools down and goes dark. This will be how our sun ends its life in the universe. The final type of future star is the iron star. These are the remnants of stars where enough time has elapsed for them to have converted themselves entirely into iron through quantum tunneling. We won't see these kinds of stars for at least 10 to the 1500th years. Number 6. Dark stars. This type of star is another one that may no longer exist, but might once have, though this is far from settled. If dark stars ever existed, they would have consisted of mostly normal matter, hydrogen and helium, but would have had a significant more amount of dark matter present within them that would generate reactions within the star. If you can call it that, that would have involved the annihilation of dark matter particles. The heat from this process would have created an equilibrium where the normal matter couldn't condense down into what we see today as a star, but rather would have been in a more diffuse situation without normal nuclear fusion occurring. These stars would be very low luminosity and would have been huge, at least several times the size of the orbit of Earth around the Sun, if not much larger. These stars likely no longer exist, if they ever indeed did, and would have long since collapsed into normal fusion reaction stars. But if they do still exist, they may be detectable. If so, we may someday see a dark star, despite its name. Number 5. Primordial black holes. The early universe was a very strange and unusual place compared to today. Shortly after the Big Bang, the densities and evenness of the early universe allowed for a way for black holes to form that doesn't happen today under the conditions of stellar collapses. Those conditions allow for the odd effect of black holes far smaller than the normal black holes that form now, as in the size of a grapefruit. While larger primordial black holes may still be around or may have formed the core material for growing black holes at the centers of galaxies, the very small ones may have evaporated by now. But there's an oddity here. If they still exist, it has been advanced that one of them might be responsible for the effects attributed to the as-yet undiscovered Planet 9. If this is the case, then there would be a bona fide tiny black hole as a member of the solar system. If it posed a threat, though, we probably wouldn't be here. But if it's out there, imagine what could be learned from a black hole so close by. Number 4. Frozen stars. One of the major factors in why the stars of today are different than the earliest stars is metallicity. The earliest stars were poor in this regard, mostly containing hydrogen and helium. As the universe began to age and through the actions of supernovas and kilonovas, heavier elements were generated, which is responsible for the generally metal-rich stars of today that contain many different elements. This process has not stopped, and as the universe ages more, there will be an increasing amount of heavier elements in the universe. This means that some stars that form in the far future may be significantly different from the stars of today. This includes an object known as a frozen star. As the interstellar medium becomes richer in metallicity, the masses stars can have will decrease. So something that would today form a brown dwarf, a failed star, in the future would become a star. This could lead to an extremely cool type of star with a surface temperature of just 0 degrees Celsius, leading to the possibility of ice clouds in the upper atmosphere of the star. These objects, however, would be very dim, far dimmer than any star today. But just like red dwarfs, they would be extremely long-lived, if a bit cold. Number 3. Electroweak stars. Unlike many stars on this list that can only have existed under the conditions of the early universe, electroweak stars are bizarre objects that can exist under the conditions just after a supernova. They are hypothesized to be denser than quark stars, being kept from collapse by electroweak burning, the conversion of quarks to leptons producing photons and neutrinos, creating pressure holding the object in an equilibrium. This would be a strange object indeed. It's thought that they would have lifetimes of only about 10 million years or so, and the actual process of electroweak burning would happen at the star's core, which would only be about the size of a baseball, yet it would be releasing enough outward pressure to keep the star from collapsing into a black hole. Extreme indeed. Number 2. Blitzars. This hypothetical type of star would be a pulsar, rotating so rapidly that it overcomes gravity, keeping it from collapsing into a black hole. These types of stars are automatically doomed, in that if they ever slow down, which they inevitably will as their magnetic fields radiate energy, until eventually they will fall below the threshold of speed and collapse. These have not been detected, but have been advanced as a source for fast radio bursts, where the burst is emitted by the pulsar's former magnetic field immediately after the star collapses into a black hole. Interestingly, there are some candidates for these stars where it's thought that the magnetic fields had previously cleared the area of dust and gas, and with nothing to fall into the newly formed black hole, there would just be a burst of radio, but no X-ray or gamma ray emissions. Number 1. Boson stars. Perhaps the most bizarre hypothetical star that may be in the universe is known as a boson star. These stars would not be normal by any stretch of the imagination. These stars would have to be made of bosons. This is in contrast to normal stars, which are formed mostly from fermions, though do contain helium-4 nuclei, which are bosons. What the boson is that would form a boson star is unknown, though there are hypothetical candidates such as the Axion. If these stars can exist, they'd be very strange indeed. First, they would be invisible, as in transparent, but they would bend light like a black hole. If such a star absorbed ordinary matter, which it very likely would, then that would be visible at its center and probably would emit detectable radiation. If the star were rotating, the invisible boson matter wouldn't form a sphere as a star normally would, but rather a donut shape. And certain takes on this type of star are interesting. One is that given that galaxies are thought to have huge dark matter halos around them, then that could be seen as a kind of boson star in itself, meaning you live inside one. These stars remain hypothetical, and at this time difficult if not impossible to detect, but in the future there may be ways to indirectly detect them. Only time will tell if this very bizarre kind of star exists somewhere out there, but there may be a hint. If boson stars formed just after the Big Bang, it's possible that supermassive ones might be found at the cores of galaxies, which would explain certain observations of active galactic cores. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently concerned about all the invisible stuff in the universe. Invisible stars, invisible dark matter, invisible dimensions, and so on. I think it's abundantly clear that the universe is hiding something. And be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live. The universe is full of both verified and hypothesized objects that do not fit neatly into the humdrum world of standard classes of planets, moons, galaxies, and well-understood phenomena. So here are 10 bizarre deep space astronomical objects that have either been discovered or may well exist out there somewhere amongst the stars. Number 10. Moons. One of the most common questions I get is, can a moon have its own moon? And the answer is yes, or so it's thought. While no example of this kind of object has ever been discovered, it's one of those instances in astronomy that seems likely to eventually happen. It's the concept of a subsatellite, or moon, where a moon of a planet has a moon of its own. While in most cases this isn't likely to occur in a planetary system, there are situations where it can, and indeed we ourselves have created artificial moons in orbit of our own moon, though doing so is tricky. There are, however, natural candidates for this. Saturn's moon Iapetus has a very pronounced, unusual ridge extending around it that may have been caused by a past moon. But even stranger is the case of Saturn's moon Rhea. Last year, what appears to be a ring system was discovered around this moon, creating the odd situation of a ringed moon orbiting a ringed planet. It was determined that if it had a ring system, the tiny moon could have a stable moon in principle. A search of the data from the Cassini mission has failed to find such a moon, but it does tick a box in favor of moons existing in the universe. Number 9. Rogue planets. At first glance, interstellar space may seem very empty other than dust and the occasional atom of hydrogen, but in reality, interstellar space also hosts an entire class of planet that sits alone from planets confined in star systems. They are rogue planets. Rogue planets typically start as members of star systems, but instabilities within those systems leads to their ejection. Indeed, it's thought by some scientists that early in the solar system's history, a Neptune-sized planet that formed here was ejected through a close encounter with Jupiter. Where that planet is now is anyone's guess. but having been ejected an estimated 4 billion years ago, it's likely very, very far away. One candidate for a free-floating rogue planet is an object known as SIMP J013656.5 plus 093347. Once thought to be a brown dwarf, the size of this planet has been constrained down to 12.7 Jupiter masses, making it seem more like a massive planet than a brown dwarf, though the line is blurred. The object is particularly interesting because variations in its light curve have been interpreted as variations in cloud patterns in its atmosphere, and indeed evidence for very powerful auroras has also been found, suggesting that the planet has a very strong magnetic field. Apart from giant worlds, there should be a population of smaller rogue planets as well, including planets that might have otherwise been similar to Earth. Interestingly, the concept of a rogue planet wandering the darkness of interstellar space doesn't seem conducive to life ever arising in such a place. But with geothermal heating, such a planet could have liquid water. Who knows where life might get a foothold, though it might seem rather sad if a rogue planet is ever discovered that had evidence of life, but that life went extinct long ago when the planet froze over in the depths of space. Number 8. The antimatter fountain. The matter-antimatter reaction is the ultimate inefficiency. If you have exactly 1 gram of matter and 1 gram of antimatter and put them together, they will violently annihilate each other in a 100% conversion of mass into energy. But there is a rabbit hole here. There is no clear reason why the Big Bang wouldn't have produced equal amounts of matter and antimatter. For some reason, not yet understood, it seems that slightly more matter was created than antimatter, allowing for the universe's matter to exist today as we see it. But antimatter can still be created, even in nature. At the center of the galaxy lies an antimatter fountain that spews massive amounts of positrons out, which then go on to annihilate on contact with normal matter. What's actually at the heart of the fountain producing this material is unknown, but hypotheses range from them being somehow created by a black hole, or even that they are somehow being created by some reaction involving dark matter, though no one knows how that would even work. Number 7. The double quasar. This entry is a kind of 1-2 punch in strangeness, not only because of the nature of what it is, but also a strange occurrence associated with it that was caught entirely by pure chance. In 1979, the object QSO 0957 plus 561 was discovered. Initially, it appeared to be 2 quasars located very close to each other, something that seemed unlikely. As study of the object progressed, it was realized that the 2 quasars were so similar that they would essentially have to be twins, making the whole thing even more unlikely. Later, instead of being 2 quasars, it was found that they were actually 2 images of the same quasar that were being gravitationally lensed by a galaxy in the foreground. This was one of the first gravitationally lensed objects ever found, and confirms Einstein's view of space-time being warped and capable of lensing objects. And there's an interesting effect with this case. Any change in the quasar is seen in one image, but because the other image represents a slightly different path, the same change is not seen in the other image for over a year later. This quasar also happens to be extremely distant at 7.8 billion light-years, and the galaxy that is in front of it, just over half that. This led to a strange incident in 1996. Astronomers caught an odd dip in the light of the quasar. Unfortunately, it can't ever be confirmed, but one idea that's on the table for this dip is that it was caused by the transit of a 3 Earth-mass exoplanet in front of the quasar. This would place that exoplanet within the galaxy that's lensing the quasar, and would be by far the most distant exoplanet ever detected, at a whopping 4 billion light-years. Number 6. Omega Centauri. The Milky Way is full of spectacular star clusters. These are full-fledged members of our galaxy having formed here, but one stands out, Omega Centauri, and it's not just any star cluster. It's very brightly visible from Earth, even at a distance of nearly 16,000 light-years, and it basically breaks most of the rules that define globular clusters in the Milky Way. For example, a typical star cluster of the Milky Way has hundreds of thousands of stars, such as M80, which is visible in small telescopes. By contrast, Omega Centauri has millions of stars. Globular clusters in the Milky Way tend to be a bit homogeneous as far as the types and ages of the stars within them. Omega Centauri is not like this at all, and contains a varied profile of stars all born at different times, evidenced by their types and metallicities. And the whole thing is spinning, which normal star clusters tend not to do. All of this points to an unusual origin for Omega Centauri. Rather than being a member of the Milky Way, it may not be from here at all, and could represent the nucleus of an entire other galaxy that the Milky Way absorbed and cannibalized at some point until all that was left was the core. This would mean that scattered across the Milky Way are stars and possibly planets from another galaxy entirely, and this process of galaxy mergers has not stopped. Indeed, we are currently careening towards the Great Andromeda Galaxy for a merger in about 4.5 billion years. Number 5. Hoag's Object. When this object was first discovered, it wasn't immediately clear just what it was. One idea is that it was something similar to the double quasar, and that it was a quasar behind a foreground elliptical galaxy that was being gravitationally lensed around it. This did not turn out to be the case, however, and as it turned out, the object is actually a cohesive galaxy, yet it's structured very differently from normal galaxies. Instead of a normal spiral galaxy structure, this object has a core of older, yellower stars, then a large gap, and then a blue outer ring of generally younger stars. There aren't any dead ringer answers on just how this came to be, but on the table is a very specific encounter with another small galaxy, where it barreled through rapidly, creating the effect. But this would have had to have happened relatively recently, and no small galaxy seems to be in the vicinity. Another is that it is the result of some type of instability that can happen in barred galaxies. Yet Hoag's object doesn't appear to have ever been a barred galaxy. No option fully explains just how Hoag's object came to be this way, and it's unique. While there are other ring-type galaxies, they are very rare, and none are quite like Hoag's object. And to add another enigmatic twist to this story, is that rare as they are, there is a second ringed galaxy at a completely different distance and totally unrelated to Hoag's object that just happens to be lined up just so as to appear within the gap of Hoag's object. The chances of two very rare galaxies appearing like that are, well, astronomical. Number 4. SN 2006 GY. It's hard to envision anything more cataclysmic than a supernova. There are two main types. Type 1, where a white dwarf gains material from a companion star until the accruing mass causes the white dwarf to begin fusing carbon and the star explodes. Type 2 is the more familiar stellar collapse of an old star, ending its life by imploding and exploding. But there appears to be a rarer third type, and one was witnessed in 2006. This was SN 2006 GY and exploded with a violence estimated to be as much as 100 times the power of a normal supernova. In essence, a hypernova. Stars that can do this must be enormous, the largest stars in the universe, and the rarest. And they don't live long. They tend to only live for a few tens of millions of years before exploding. While it's not entirely clear how these massive explosions occur, one idea is that stars this massive produce gamma rays, and that in turn can create matter-antimatter pairs. This creates a matter-antimatter reaction as they annihilate each other, which then goes out of control inside the star, causing it to collapse and explode. This type of supernova is odd in another way. In a normal Type 2 supernova, a neutron star is left behind, but in the case of these giant supernovas, the star is entirely blown up. And another of these is coming, and it will be much closer. SN 2006 GY was in another galaxy entirely, but the Milky Way star Eta Carina is just this type of star and could explode at any time. When it does, it won't pose a threat to Earth, but it will be a spectacular sight and will probably be visible from Earth even in daylight for a time. Number 3. Thorne-Zeitgau objects. These strange objects are still only hypothesized to exist, though there are candidates for them, and they likely do exist, though are probably very rare and probably limited to very dense areas of stars, such as globular clusters, and in very special circumstances in binary star systems. So rare that there could be as few as 20 of these objects in the Milky Way at any given time. A Thorne-Zeitgau object forms when a neutron star collides with a giant star and essentially becomes engulfed within it. If the combined two are of a high enough mass, the whole thing will collapse into a black hole, and probably creating yet another type of supernova. If not, the strange state of affairs will eventually result in a single, more massive neutron star. While no confirmed Thorne-Zeitgau object has ever been discovered, there are several candidates. One particularly interesting system is where an F-type star is being orbited by an unseen object, likely a black hole. It's thought that this system, GRO J1655-40, might have went through a stage as a Thorne-Zeitgau object. Number 2. Stephan's Quintet. This strange case is an instance where one solved mystery leads to another. That is not uncommon in science, to say the least, but in this case, solving the first mystery ended up reopening the very same question. The objects in question are a group of galaxies known as Stephan's Quintet, and the mystery involves redshift. Redshift is a major way of determining distance and motion in the universe, in this case, the distance to these galaxies. At first glance, the galaxies in the quintet appeared intertwined, as if they were all physically connected with each other. But there was a problem. The redshift of one of the galaxies, the one at the lower left, indicated that it was only about 300 million light-years away, whereas the rest were 10 times more distant. So, how could they be interacting? Were scientists completely wrong about redshift? This led to questions about whether redshift can be trusted. This was an uncomfortable prospect, because if it had been wrong, then we'd be wrong about distances in the universe, and even the size of the observable universe. It wasn't until the year 2000 that the mystery was finally solved using the Hubble Space Telescope. They imaged the galaxies and found that the oddball galaxy's individual stars could be resolved, and the other galaxies could not be. In short, it was an optical illusion, and the oddball galaxy had to be 10 times closer, and the reliability of redshift was safe, or was it? Not long after, the mystery arose again in the same group of galaxies. Another of the galaxies had an odd star-like feature near its nucleus. Spectroscopy showed that the object is in fact a quasar with an enormous amount of redshift, suggesting that it's billions of light-years further away than the galaxy is. Yet it appears to be in front of the galaxy and interacting with it. In the end, Stephan's Quintet opened up more questions than it answered. Is there something wrong with redshift? Is there just a chance hole in the galaxy that allows the quasar to be visible and the interaction is just an illusion? Is there something wrong with our interpretation of quasars? The questions are open. Number 1. Diamond planets. Carbon is a very common element in the universe, and indeed forms the basis for the chemistry of life itself. In protoplanetary disks, it should be possible that ones rich in carbon but poor in oxygen might exist. These would in turn form a very different kind of planet to anything in our solar system, a carbon planet. While there is at least one candidate for this type of planet, 55 Cancri, none have been confirmed. That particular planet seems to have a surface made up of graphite and diamond, but it's also very hot. Carbon planets would be very different planets indeed. If a carbon planet that has sufficient pressure internally, it might maintain a thick layer of diamond from which material might be transported to the surface through volcanism, creating diamond volcanoes, such as what might be happening at 55 Cancri. Cooler versions of these planets might sport liquid hydrocarbons on their surfaces, but what they probably wouldn't have is water. That doesn't preclude life on a world like this any more than it does on Titan, but that life would probably be forever microbial, if it could happen at all. But within this is an even stranger object that probably can't be called a planet, though it would look like one. Orbiting the millisecond pulsar PSR J1719-1438 is a planet-like object that appears to be almost entirely made of solid diamond. And it's known to be very small, yet has a mass similar to Jupiter, but this object didn't start out as a planet at all, but rather a star. The spherical chunk of diamond is the remnant of an apparently evaporated white dwarf. In short, it's a diamond star cinder. Thanks for listening. I am futurist and science fiction author John Michael Godier, and be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live. There's little question that SpaceX's launch of Falcon Heavy was historic. This is a truly huge development in the exploration of space that allows an expansion of our heavy lift capabilities, but has also rekindled interest in space simply by virtue of launching something unusual, Elon Musk's Tesla Roadster. The Roadster launch garnered the attention of tens of millions on YouTube alone, making it well worth it as far as science outreach and inspiration goes. But launching odd items into space in general is nothing new, and in fact, the Roadster might not even be the strangest object ever launched. So here are 10 really unusual items humans have launched into space. Number 10. Mutating tomatoes. Flying tomatoes into space on its face isn't surprising. They are a popular food item. But what happens when you fly them just to see what space does to them when you grow them back on Earth? Oddly, this has happened multiple times. The first story here is rather murky, the cosmonaut Volkov tomato. Heirloom tomato gardeners will probably know of this variety of tomato as it's commonly available in seed catalogs. But how did it get the name of a famous cosmonaut? As it turns out, there are two stories floating around. One is that the Soviet Union launched tomato seeds into low Earth orbit and then distributed them for cultivation after landing to see if exposure to space did anything, and it's been bred ever since. Another is that a Soviet space program engineer developed the strain here on Earth and simply named it after his friend, cosmonaut Vladislav Volkov, who died in an accident in space in 1971. Regardless of which account is true, someone bringing tomato seeds into space and returning them safely to the Earth to see what would happen is a certainty. Back in the 1980s, NASA brought them up on the space shuttle and then left them on a satellite, then retrieved them sometime later and distributed the seeds to schools for in-classroom experiments. Everything was all fun and games until someone suggested that exposure to cosmic rays could have mutated the tomatoes and made them poisonous once grown. It turns out they were fine, and even more seeds were sent to the ISS in 2016. Those, however, stayed safely in the space station and were mostly just subject to a period of zero-G. I haven't eaten any of NASA's space tomatoes, but I have grown cosmonaut Volkovs, and they're delicious. Number 9. Dinosaurs. Not only have the dinosaurs been to space, but twice, though they weren't alive at the time. In 1985, 76-million-year-old bits of bone and shell from a Maiasaura peoplesorum were flown on Spacelab 2 for no other reason than it seemed like a cool idea at the time. In 1998, a small dinosaur skull was flown to Mir and returned to Earth, again because it was cool. I certainly get the concept of science outreach and doing cool things in space just because they're cool, but somehow I doubt the dinosaurs would have been too happy with this, especially in light that their extinction was directly related to space. Number 8. The man who discovered Pluto. I doubt astronomer Clyde Tombaugh would have ever thought, as a young man, that he would go on to discover a planet, and then that planet got demoted to a minor planet, and then Tombaugh would go on to fly past that planet, yes, planet, at a breakneck speed and then rocket off into space to become the furthest human as such from Earth. But that's what happened. While studying photographic plates using a device called a blink comparator to look for minute movements of objects in space, he ended up discovering Pluto. He also discovered quite a few asteroids using this method. A sample of Tombaugh's ashes were included on the first spacecraft to visit Pluto, New Horizons. And if that's not cool enough, Tombaugh may technically become the first human to leave the solar system. Who knows where his ashes will end up? But oddly, also included on this mission was a nuclear power source consisting of plutonium. This element was named after the planet Pluto to keep in line with the then current naming scheme of newly discovered elements. They were named after planets, such as uranium and neptunium. Trouble is, Pluto has been demoted, which makes it sort of ridiculous that we have an element named after a former Kuiper Belt object. But good luck renaming plutonium. Given that New Horizons also revealed that Pluto was far more interesting of a world than we could have ever imagined, and it's so ingrained in global and scientific culture, Mickey Mouse's dog is named after this thing, I think maybe we should start calling it a planet again, or at least give it its own classification, perhaps call it a plunaut. Number 7. Really crazy handguns. You normally wouldn't think you'd need a gun in space, and even if you did, firing it in an airtight spacecraft would be beyond dangerous, but for years Soviet cosmonauts were in fact equipped with firearms, and they were no normal handguns, they had triple barrels. The reasoning for packing heat was simple, and it had nothing to do with encountering hostile aliens. The truth is, capsules parachute landing in Siberia might not be immediately retrievable, leaving cosmonauts on their own until help arrived. Given that there are dangerous animals living in Siberia, such as bears and wolves, it was deemed necessary for the cosmonauts to be ready to defend themselves if need be, or even hunt. Number 6. Delivery pizza. It's the age of pizza. From its simpler, though really delicious beginnings as a local food in Naples, Italy, this food has taken over the world, and pizza restaurants serving hundreds of variations can be found ubiquitously in numerous countries, and that trend grows. One of the hallmarks of pizzas is that they are easily delivered if the customer wants to order in, and they make for awesome leftovers the next day. But has pizza left Earth? Yes, in the furthest reach of pizza delivery so far, Roscosmos delivered a pizza to the International Space Station in 2001. Commissioned to do so by Pizza Hut and costing that company over $1 million, the delivery pizza was consumed by cosmonaut Yuri Yusakov. But exposure to low Earth orbit conditions deadens taste buds, so the company spiced the pizza up a bit more than usual and had to use salami as a topping due to the delivery taking far longer than the usual half hour, raising questions about toppings and shelf lives in a space capsule traveling to the ISS. Even still, the cosmonaut gave a thumbs up after dinner and seemed to enjoy it. Number 5. Golf equipment. In 1971, NASA astronaut Alan Shepard famously pulled out a golf club and shot a few golf balls on the lunar surface during the Apollo 14 mission. While we don't know the actual numbers until someone actually goes up there and finds the golf balls if they haven't disintegrated and actually measures it, this was almost certainly a semi-permanent golfing record, as one of the golf balls may have gone for miles. Oddly enough, this was probably not sanctioned by NASA. Story is, Shepard smuggled a makeshift golf club head on the mission and mounted it on a lunar sample-taking instrument and just went ahead and took the shot. That makeshift golf club made it back to Earth and is displayed in the USGA's museum. Number 4. A poster for a minor Val Kilmer movie stuck to a wheel of cheese. Alright, this was SpaceX again and Elon's humor. In 2010, it was revealed that aboard SpaceX's first Dragon capsule, there was a wheel of cheese, a nod to a Monty Python sketch where John Cleese wanted to buy cheese from a cheese shop that didn't carry it, along with an image of the movie poster for the Val Kilmer movie Top Secret. Anyone remember that one? Oddly, this time SpaceX chose to keep their cargo secret until after the launch, as not to overshadow the success of Dragon. With Falcon Heavy and the Tesla Roadster, clearly they have gotten over this shyness about their occasionally odd cargoes. Number 3. Salmonella. It's only natural to study Earth bacteria in space. What can be learned from doing so can shed light on human illness and treatments. Salmonella is no exception, and it was flown twice on the space shuttle to the International Space Station. While it may not be all that weird to fly salmonella, what happened to it while it was in space certainly was. You would think taking an organism out of its native environment would put it at a disadvantage and weaken it. Not in this case. The salmonella became 3 to 7 times more dangerous after spending time in space. It appears that the bacteria were tricked into thinking that they were inside a human body rather than space. This is believed to be because of fluid shear. Once they attach themselves to the walls of human intestines, the salmonella bacteria experience a condition of very low fluid shear, which might signal them to switch on certain parts of their genome and, well, become more dangerous and make their host sick. As it turns out, zero gravity is also a low fluid shear environment. Number 2. Nudes. Clothing on Earth is a cultural thing. Most human cultures prefer some form of it, especially if they are native to cold climates, but not all. As a consequence, it may be that the entire galaxy is clothing optional, depending on the species and culture and the environment they evolved in. Though I would say it might be reasonable to expect one piece of clothing that might be common among most biological spacefaring species, the spacesuit. That aside, if you look at most representations of humans in our cultures, our photographs, other technological records of us, say our television broadcasts that aliens might intercept, they would see us as a strangely clothed species. Perhaps the aliens might wonder if Batman's suit was really a part of his body, or they might think the whole thing's silly and wonder why we once restricted ourselves with steel armor in battle instead of genetically modifying ourselves to grow a decently protective carapace. But some scientists on Earth would have no part of this clothing thing, and felt it best to depict humans as we really are. It was Carl Sagan, Eric Burgess, and Frank Drake, and they rightly surmised that, well, one thing about humans is that we're all naked under our clothes, so Sagan went with depicting humans as humans in all our glory. It's the Pioneer plaque, and there are 2 of them, one on Pioneer 10 and one on Pioneer 11. It's actually pretty unlikely anyone will ever intercept our nudes we've sent out. In fact, it may be more likely that we intercept them and take them back to museums in the future. But if left on their own, the plaque on Pioneer 10 will eventually pass near the star Aldebaran, and then on to parts unknown. It's anyone's guess what Pioneer 11 will eventually encounter. In other words, we've lost control of our nudes and they are happily gallivanting across the galaxy. Number 1. The nuclear manhole cover. This one may or may not have made it into space. This is something that has been debated for years, but if it did, and we'll likely never know, it would be among the first man-made objects into space and probably the strangest. It all goes back to a nuclear test conducted in 1957. During this test, a 2,000-pound steel plate was placed atop a test shaft. As the experiment detonated, it traveled up this shaft and propelled the plate into the air at about 6 times the escape velocity of planet Earth. What happened then is anyone's guess, though no trace of the plate was ever found. It might have vaporized in the atmosphere, or some parts of it might have made it into space and off into the solar system and beyond. So count Elon Musk's Tesla Roadster as just the next in a long series of odd objects we've sent into space over the years, and we should send more. Who knows who might pass through the solar system and find our remnants floating in space. After all, one species' trash is another species' confirmation that they are not alone. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently worried about the Mad Max movies. In such a scenario, I want the Tesla electric driverless thunder vehicle. Mel Gibson always had to worry about gasoline. Don't have to worry about that with solar panels and batteries. And even when he had gas, he still had to keep his eyes on the road while others repelled the marauders. Seriously, like the last 20 minutes of Road Warrior is everyone fighting while Mel Gibson just sort of drives. Tesla could fix this, but we're gonna need some gun turrets. And be sure to check out my books at your favorite online book retailer and subscribe to my channel for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live. There has been one certainty across the entire history of humanity that quite literally everyone that's ever lived faced. It's death. Even taxes aren't as certain, as there have been humans in the past that had no such concept. As a result, humans throughout history have toyed with the idea of immortality and defeating death. But here, a distinction must be made. Many peoples throughout history believed and believe in non-physical immortality. That one must be left to the spiritual. But actual physical immortality within the universe may be possible, at least in a practical way. Eventually, true immortality may be unachievable, as the universe itself isn't immortal, at least in its present form. So here are 10 hypothetical ways you could end up functionally immortal, including unintentional ones where you have no choice. Number 10. Digital immortality. Digital immortality, or at least the prospect of it, is nothing new. The first scientific paper advancing the concept came out in 1971, and in a nutshell, the idea is that you could, in principle, scan or otherwise transfer the contents and operations of a human brain into a machine and thus make a copy. Alternatively, you could, in principle, gradually replace neurons in a human brain with artificial neurons, slowly transferring the information and consciousness of that brain onto a digital medium. This would in effect allow one to upload themselves into a computer. Whether it would be the same consciousness and you would remain you is still debated. However, the effect is the same either way: immortality through backup. Any number of backups of you could be made, and even allow for you to interact with your backup, as strange as that might be. But this is functional digital immortality so long as there is a system preserving your program. And as each iteration of you is destroyed, another you could be made from the backups. Or it could simply be that the human brain does not transfer and only emulations of it can be made. You yourself simply can't transfer. But in this case, it opens up an interesting future possibility. If you can't transfer and thus die, your backup digital emulation would still be around. One can envision future tombstones sporting a fully interactive, artificially intelligent representation of you for anyone visiting to talk to. Number 9. Physical immortality and cloning. Physical immortality in the sense of remaining a biological being that lives forever is a truly ancient idea, perhaps originating in the early days of human prehistory. After all, it's easy to imagine someone that simply doesn't die. But actually defeating the aging process and preventing natural death eludes us, and it comes with two problems. The first is that, statistically speaking, the chances of you having a fatal accident eventually catch up with you after about 10,000 years. You can live a long time, but chances are at some point you get vaporized or hit by an asteroid. The other problem is that we simply just aren't designed for immortality. That said, we have been fairly successful at extending the human lifespan. Our prehistoric ancestors were, for the most part, gone by age 30, and even just 300 years ago, hitting 50 was somewhat uncommon. Some have suggested, however, that some people alive today will catch a curve of life extension technological development and may still be here centuries from now, so long as the technology continues to develop from there. But getting to biological immortality is the key. One way is cryonics, essentially freezing yourself, along with vitrification agents to protect your cells, and then staying that way indefinitely until whatever killed you can be cured, the damage to your body repaired, and then you can be woke up. If you wake up at a time where biological immortality has been achieved, then you've made it to immortality simply by trying to survive a disease. Presumably, any attempt to wake up a frozen time traveler would involve nanotechnology that can repair a body from within. This would be all important because when you freeze someone, it doesn't simply completely stop the damage being done to the body. Just the natural radioactive elements in a human body that's frozen will damage it over time. Cloning may also be of use in this approach, especially for those that have elected to only have their head frozen. While there's plenty of reason to be skeptical that this technology could ever result in resurrecting people, it's an interesting idea. And you have to ask, alright, you're legally dead for now, but not really, which would mean that the oldest still frozen cryonics participant would now hold the record for the oldest living person at currently 130 years old, should it ever be possible to wake them up. Number 8. The past is immutable. Think carefully about the nature of time. It's one of the strangest aspects of the universe. In one way, you could say that time is a continuum. It progresses from one event to the next. But think of another type of universe, where if there had not been tiny anisotropies or temperature differences in the unfolding of the Big Bang, the universe would consist of a kind of lattice of equidistant hydrogen atoms that never do anything. It would essentially be a timeless universe, where trillions upon trillions of years pass with little to nothing happening. Indeed, if the proton never decays, it would go on like that forever. Time, in that context, would be meaningless. But that's not our universe. Rather, our universe is one where the past defines the future, cause and effect. The effect being determined by the cause. That suggests that perhaps the past is immutable, and somehow still back there like a recording. Indeed, the Big Bang itself, the moment in which time itself began, still continues to define our universe. The question of whether the past continues to exist is a huge one, but in sci-fi it has led to many stories of time travel, from H.G. Wells' book The Time Machine to many modern interpretations that play with ideas of time, past, present, and future. You can find it from Star Trek to cult classic movies like The Fountain. But what does time viewed as a tangible thing really mean? Well, not the least of which is immortality. Think about it, if someone could travel back in time and visit a world of the past, then everyone in that past still exists in a very real, visceral way. Every bit as real as you and I are, and indeed, if backwards time travel were possible, we would be the past for someone else. In other words, as long as the universe exists, so does its tangible past in this interpretation. And thus, you achieve immortality in time. Number 7. Immortal from a distance. The speed of light is often seen as a limiting factor. So far as we know, you cannot exceed it. This is a greater problem than many people realize, because not only is it the highest speed an unimpeded photon travels at, it's also the fastest speed you can send information. The slowest time can dilate, meaning it stops, and also the speed at which it requires infinite energy to even reach if you're made of matter. Many things coincide at c, and that's not a coincidence. But the effect of the speed of light on the transfer of information and how time operates is interesting. Einstein's theories of relativity show us that to a star system 500 light years away, you haven't been born yet. Yet you, your life, your experiences, and so on will not reach that point before you die. The entirety of the information of your existence, no matter how minuscule it would be propagating across the universe, due to the expansion of the universe, could travel forever, meaning that while you didn't achieve digital or biological immortality, you did do it in physics. But what you can't know in this case is the history of your own world, because you can't ever catch up to light without infinite energy. You can never see the history of Earth, much less anyone after the history of you. In this case, functional immortality is an exercise of looking at alien civilizations as they once were. But the catch is, past a certain point, no one can ever look at themselves. The universe is a very strange place indeed. Number 6. Many worlds. Few ideas within theoretical physics are as outright odd as the many worlds interpretation. Essentially, this interpretation presents a situation where that all that is possible to happen does, and results in timelines constantly splitting off from each other in a near infinite number of combinations. All that is possible to happen will happen in alternative timelines. This can range from the relatively mundane. One atom in your environment is in a different position in an alternate timeline, and that's the only difference. But it can also range to the radically different, where a very different human future results from the choices made before the branching of the timelines. Given that we may be very close to life extension and functional immortality right now, if we don't quite make it there within our lifetimes, there could be branch timelines where humans did make it past the immortality hurdle in time. This would mean that alternative timeline versions of you are immortal, but other alternative timeline versions of you are not. If the many worlds interpretation is correct, immortality, at least at this point in time, is the luck of the draw of whatever timeline you happen to be in. Number 5. Cyclic cosmology. Physicist Roger Penrose has advanced a hypothesis that the universe is really just one iteration of a cyclic cosmology, where a Big Bang happens, a universe unfolds, and then at some point another Big Bang happens, and it just repeats over and over, perhaps infinitely. It may be the case that each of these iterations of the universe are different from each other, and there may have been past universes that didn't allow for life. At the same time, though, one of the potential ways to test this hypothesis is to look for evidence of the last universe's population of black holes in the cosmic microwave background radiation. If that pans out, then at least the most recent previous universe was close enough to this one to allow for the existence of black holes. But here's the kicker. If this idea is valid, then we don't actually know how far this goes. It could also be that each iteration of the universe is identical, with the identical timeline, with an identical you appearing over and over, living the same life, one iteration after the other, for eternity. In short, you may only be here for a short time, but you get to live again an infinite amount of times. Number 4. The simulation hypothesis. One of the spookiest areas of modern philosophy is the question of whether the universe is a simulation. On the one hand, the sheer bizarreness of quantum mechanics and physics might suggest that it's far too messy to be a simulation. But from the standpoint of human technology, we can see a day where at some level we might be able to create simulations of sufficient complexity to start looking like a universe of sorts. And then there is the overarching problem that if the universe is a simulation, there may be no way for us to tell. Simulation theory aside, however, there is also the question of data storage from the simulation. Is a record of the simulation made from start to finish, including that of your own existence? Can that part of the simulation be revisited by the simulator? A kind of rewind button where your time of existence is replayed for some purpose that lies outside the running simulation. If every aspect of your existence is preserved in such a way, so long as the record exists, you are functionally immortal. Number 3. Boltzmann immortality. Infinite time is a strange thing. If you have it, then everything that is possible eventually happens. This led Ludwig Boltzmann to present a thought experiment. If that's true, then if you wait long enough in a universe of infinite time, then a thinking, conscious brain will randomly assemble, at least for a time. This is usually seen as a glimmer of consciousness every now and again in a dead universe. But when you're dealing with the notion that any possible thing will happen, then it expands. It may be that your own consciousness pops in and out of existence in infinite time, complete with your memories, and for all intents and purposes is you. Of course, this option also suffers from the same issue as digital transference of consciousness. What makes up you, as in your consciousness, may not translate to the random copy of your mind that may, or may not, pop up in an infinitely persisting timeline. But if it does, then it represents a kind of built-in immortality option in the universe itself, should time indeed be infinite. Number 2. The infinite universe. As with the possibility of infinite time, there is also the possibility of infinite space. We can only ever see a bubble of the universe, the observable universe, but we know that it extends further out, but by how much we have no idea. There is the option, however, that it extends infinitely, and that leads to the strange situation of if you travel far enough, you will come across an almost exact copy of Earth, and even you. Or possibly an exact copy for all intents and purposes. But what's not often pointed out is that it need not exist at the same time. In an infinite universe, a variation could happen where a copy of Earth appears 30 billion years later than this one. Or at any point, really. It is, after all, infinite. This represents a sort of immortality. Once your time is done, it's done. But there may be copies of you that appear throughout the habitable history of the infinite universe. Number 1. The Poincaré Recurrence Theorem. There's no question that hidden within the realms of mathematics and physics, there are many strange things, counterintuitive to the world in which we live. Everything from quantum non-locality, spooky action at a distance, photons that do not experience time, and a barrel of others that are yet to be fully rectified with what we view as reality. One idea hidden in here is the Poincaré Recurrence Theorem. Formulated by Henri Poincaré in 1890, it essentially boils down to this. In mathematics, certain systems, after you wait a long enough but finite time, will return to their initial state. In other words, history effectively will repeat itself, so long as the theorem applies to the universe itself, which is an unanswered question. The related Poincaré time is the interval of time that it takes to do that. But that's the big problem. The Poincaré time is very likely to be so long that the universe may simply go through another Big Bang and create a new universe before it ever gets back around to everything returning to a previous state. Or maybe we might exist as a result of the Poincaré recurrence theorem, and we are just a return to the universe as it once was, and will be again. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently concerned about ending up immortal twice. Not good. And that just seems like a lot of work. And be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular, in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live. The local neighborhood of objects near the Sun is rather extensive, consisting of small stars, larger ones, brown dwarfs, interstellar objects, and so on. All are interesting in their own right, but some star systems nearby the Sun stand out. So here's a sampling of 10 of the nearest systems and what they are like. Number 10. Ross 128. Located at about 11 light-years out is the red dwarf star Ross 128. This is a very low-mass star, at only about 15% of the mass of the Sun, and if you were near it, it would look much, much dimmer. But it's also a very old star, determined by low amounts of any elements other than hydrogen and helium, placing it nearly 10 billion years old, twice the age of the Sun. Most interestingly is that this star has been found to have a planet. Known as Ross 128b, it's thought to be just slightly larger than Earth. This planet orbits very close to the star and is most likely tidally locked, always presenting the same face to the red dwarf, and seems to be on the inner edge of the habitability zone of Ross 128. The question of whether it might indeed have life is a complicated one. Red dwarfs, when they are young, tend to be violent and flare a lot, disfavoring a world like this from being habitable. Yet Ross 128, while it does flare, is on the quieter side of that due to age. If an atmosphere was able to survive on Ross 128b, then it's conceivable that the conditions might be right for liquid water and life now, or not. Oddly, Ross 128 was also the source for one of SETI's biggest false alarms. In 2017, a radio signal was picked up by the Arecibo Radio Observatory that appeared unnatural and seemingly coming from the star system. The signal wasn't picked up again by other telescopes, but what they did pick up was a lot of human-made interference. Given Ross 128's position in the sky, it turns out that in the same area there are lots of geosynchronous satellites, and it seems most likely that the signal was a satellite downlink, and not likely to have actually originated from the star. Another interesting thing is that Ross 128 is currently moving towards us, and in about 70,000 years it will pass just over 6 light-years from the Sun. One can imagine that with 70,000 years of technological development, the star may one day be seen very close up by human eyes. Number 9. Epsilon Eridani. This star has the distinction of being visible to the unaided eye from most of the surface of the Earth. Located in the constellation Eridanus, this star is about 10.5 light-years distant. This star is considerably younger than the Sun, estimated at only about 1 billion years old. It could be called sun-like, but not very much so, being a Type K orange dwarf. Given its youth, this makes for a somewhat more active star with strong solar wind. Epsilon Eridani seems to have a giant exoplanet orbiting it, though this is not fully confirmed, but at this point seems probable. We also know that this system hosts 2 asteroid belts. While not a certainty, these belts may be maintained by a second planet. We also know that this system has a really extensive debris disk, not unlike our own Kuiper belt, which is probably home to planetesimals left over from when Epsilon Eridani formed. In the past, this star has been subject to several science fiction stories and has been periodically checked by SETI just in case, but it's unlikely that this star has had time to develop any kind of intelligent species. Though it may have life itself, it's perhaps in a simple form at this stage, as orange dwarfs seem to be good candidates for habitable planets, and they last significantly longer than stars like our Sun do, so there will be more time for evolution to do its magic, should there be a suitable world in that system. That's if humans don't colonize any planets that might be there as we spread out into space before intelligence has had a chance to arise on its own there. Number 8. Luyten 726-8. Despite being one of the closest stars to the Sun at 8.7 light-years, the system was not discovered until 1948. The system is made up of a pair of very similar red dwarf stars that orbit each other about once every 26 years. The system actually used to be closer to the Sun, at just over 7.2 light-years, but has moved away since. Both are flare stars, and in fact one of them serves as the archetype for that class of star, the UV Ceti-type variable star, but one member of the system is rather extreme in its changes in brightness. In 1952, the star was seen to increase in brightness so rapidly that it increased by 75 times in only 20 seconds. While this double star system doesn't seem likely to have planets, it may actually threaten another entry on this list that might, Epsilon Eridani. In just over 30,000 years, this system will pass close enough to Epsilon Eridani to disturb its Oort cloud equivalent. This could send a hail of comets into the Epsilon Eridani system, conceivably setting up an extinction event on any planet that might harbor life there. Number 7. Sirius. Sirius is especially noteworthy in that it's the brightest star in the night sky. Sirius is close at only about 8.6 light-years and comprises a binary star system. Interestingly, this system is only going to appear to get brighter for the next 210,000 years as it moves closer to the solar system. After that, it will gradually dim until it is no longer the brightest star in the night sky. The system is young, only about 200 to 300 million years old, and consists of the principal star in the system, Sirius A, a bright bluish star about twice the size of the Sun, and Sirius B, a white dwarf which just over 100 million years ago swelled into a red giant, and then settled down to become a white dwarf. This is also in store for Sirius A in less than 1 billion years. This short lifespan makes this system unsuitable for life as we know it, at least. But there is one other aspect of the Sirius system that should be explained. Over the years, television programs and popular books have made the claim that the Dogon people of West Africa were impossibly aware of the companion star to Sirius A before such a thing could be detected, as it's nothing close to being visible to the naked eye. This was reported about a century ago by an anthropologist who was apparently unaware that previous visiting scientists looking to observe a solar eclipse might have told stories about the telescopic discovery of Sirius B, which was confirmed and observed in 1862, and that the Dogon might have been telling him about that. Then everything sort of went off a cliff in the 1970s, where people were claiming that the Dogon had contact with aliens from the Sirius system, and many books were sold. Trouble is, the Dogon are still around, and no one at the time seemed to think to go out and ask them for a clarification. In the early 1990s, further anthropological work found that none of this was quite the case. They found that the Dogon did revere the star to some degree, not surprising since many different peoples have, and it's useful in agriculture, calendars, navigation, etc. But they seem to no longer have a coherent narrative surrounding the star as had been reported in the 70s and 80s pop culture. To some within their group, its appearance announced the beginning of a festival, but others said it was actually Venus, and sometimes the two were interchangeable. What they did seem to agree on is that they first learned information about the star from Western anthropologists rather than an alien. They even remembered specific names. Number 6. Teegarden Star. Teegarden Star lies about 12 light-years from our solar system, and is another red dwarf. Not surprising since they are by far the most common types of star in the universe. This star was unknown until relatively recently. It was only discovered in 2003. This in itself opens up a question. If dim red dwarfs like Teegarden Star can remain undiscovered until modern times, then do other dim red dwarfs nearby remain undiscovered? That seems likely, and in the coming decades, more may come to light, and they may be very interesting indeed. Teegarden Star, however, is barely a star at all, just slightly more massive than a brown dwarf. But the star system seems to host at least 2 Earth-sized exoplanets, both of which are marginally within the habitable zone of the star. It's hard to say whether these planets have maintained atmospheres and could have liquid water. That's still debated. The possibility of life is an even greater question. But this star system does illustrate that it's conceivable that the most likely star systems nearby our solar system that might harbor life may yet remain undiscovered. Number 5. Lalande 21185. Another red dwarf, Lalande 201185, sits at about 8.3 light-years away. Though this is shrinking, and in just under 120,000 years, this star will pass only 4.6 light-years from the Sun. The star has been known for a while. The Lalande catalog dates from the early years of the 19th century. This star, while oddly classed as a variable star, is actually on the calmer end of things for a red dwarf. Most noteworthy about the star, however, are claims of a planet. This was actually one of the earliest claims for the detection of an exoplanet, going back to 1951, a time when it would be decades before we even confirmed the existence of planets outside the solar system, though in fairness, they were strongly suspected to be out there. But in 1974, the claims for the system were refuted, and it seemed that the system had no planets that were detectable at the time. Oddly, the same researcher that refuted the earlier claims would go on to announce the discovery of planets in the system in 1996. This world has also been called into doubt over the years, at least until the Keck Observatory seemed to have found indications of an unpredicted close-in planet in this system. Further study has shown that this planet is probably about 3 Earth masses, and whether it's actually there would be in an orbit that would place it too close to the star to be habitable. But given the changing nature of the question of whether the star system has a planet or multiple planets, more could very well be discovered. Number 4. Wolf 359. This star is a case where science fiction meets reality. For science fiction fans, this star was most famously the setting for the Battle of Wolf 359 between the Federation and the Borg in Star Trek The Next Generation, where things got just a little too close to Earth for comfort. But the star actually does really exist, and while little was said about it in Star Trek, it's actually quite an interesting neighbor to the Sun. Located just 8 light-years away in the constellation Leo, Wolf 359 is a very dim red dwarf, even after being one of the closest star systems to us. The reason for this is that it's very faint and low mass, about 9% that of the Sun, and not that much larger than Jupiter, and is actually cool enough to allow for chemical compounds to form within it without being destroyed. But the star is also magnetically very active, more than the Sun is, and as a result is another flare star that undergoes sudden increases in luminosity, including X-rays. This particular star was first of interest to German astronomer Max Wolf, who was looking at the proper motions of stars, or how fast they appear to move through space. A high proper motion typically indicates that a star is close, though not always. Wolf's work was to catalog stars with high proper motions, and to this day the catalog remains in use, hence the term Wolf 359. It's number 359 in the catalog. But there's one aspect of Wolf 359 that makes it really interesting to a far future humanity. This star is fully convective, which means that it circulates its hydrogen throughout the star, including refueling the core, and it seems to be relatively young. This means that this star is going to last a ridiculously long period of time, to the tune of 8 trillion years. In comparison, the Sun will go red giant in about 4.5 billion years, and that's where exoplanets come in. In 2019, it was found that this system may have at least 2 planets within it. In the far future, perhaps some planet around the star might make for a second home for humanity, one that will last far longer than our system of origin in its current state. Number 3. Tau Ceti. This star system differs a bit from many of the other entries on this list because it isn't just some tiny dim red dwarf, but a very sun-like star. Tau Ceti is a little smaller than the Sun, about 78% its mass, but it's very similar in many other ways, and shares the same Type G classification as the Sun. If you were nearby on a planet in this system, this star would look a lot like the Sun. Currently located 12 light-years away, Tau Ceti is notable for being really calm, actually more so than the Sun. And there is certainly material in this star system. It's a very dusty place with as much as 10 times what we have in this star system. More on that in a minute. And it's a problem for an otherwise important star to SETI searches. In addition to being similar to the Sun, Tau Ceti is believed to be older, though this is debated, but possibly as old as 10 billion years or more, but probably closer to 5.8 billion years, or maybe a little younger, which, either way, would in principle give evolution on any planet in the system within the habitable zone plenty of time to form life and a civilization based on what happened here on Earth. The habitable zone of this star would be closer in than it is in our own solar system, but not that close in. It would land about the orbit of Venus if Tau Ceti were our Sun. All of the similarities between this star system and our own have led to past SETI searches for signals to no avail, and while Tau Ceti does appear to have planets, at least 5 to date, 2 apparently within the habitable zone, we hear nothing. But then comes the debris, and that might provide an answer. This system appears loaded with comets and asteroids, and that's a problem for life, at least of any complexity. While simple life on these planets may exist, and maybe even more complex forms of life occasionally, it seems likely that things would simply get reset by impacts at a rate far higher than they happened here. On the other hand, the bulk of this debris seems to be outside of the habitable zone, which may change the equation. Regardless, this remains one of the best close-by systems in which to search for evidence of life in general. Number 2. Scholz's star. This red dwarf is interesting because we have apparently already interacted with it. Located at about 22 light-years distant, this star wasn't discovered until 2013. After further research in 2015, it was announced that this star passed through our solar system's Oort cloud about 70,000 years ago. This star is thought to be a binary system, with the main star being a red dwarf and an orbiting brown dwarf, and they're similarly aged to the Sun, with a minimum age of about 3 billion years old, but could be as much as 10 billion. This star's encounter with our Oort cloud is a little disconcerting. The reason is that it may have disturbed the Oort cloud when it passed by, and that any comets disturbed from the cloud at that distance aren't here yet. Don't worry, they won't be here anytime soon. It's going to take nearly 2 million years for them to get here, but it's conceivable that they may do some damage to Earth. but will probably either be long gone by then or advanced enough to mitigate any threats posed, or so we hope, though at this point we have plenty of warning time. Number 1. Alpha Centauri, Proxima Centauri, and Proxima b. Recently, an old question about the closest group of stars to us was answered. The question was whether Proxima Centauri, the closest star to the Sun, was actually a member of the Alpha Centauri system, or was just a free agent passing close by that system. It was found, however, that it is indeed a member, and is gravitationally bound to those stars. The main star system itself is called Alpha Centauri, which is really 2 stars. These stars are quite famous, but oddly they usually aren't mentioned under their official actual names, Rigel Kentaurus and Ptolemy. They are both Sun-like stars, one being Class G, very much like the Sun, and only a little larger, and the other is Class K, which is smaller and cooler. While these stars may be of interest to a future humanity due to their proximity and similarity to the Sun, the third member of this system is of particular interest right now. Orbiting somewhat distantly from the main pair is the red dwarf Proxima Centauri. This is actually the true closest star to the Sun at just 4.24 light years. This star has a known planet, thought to be a bit larger than Earth, within its habitable zone. This planet, known as Proxima b, is of great interest in both the search for life on other worlds and the study of exoplanets due to how close it is. But there may be other member planets of the Alpha Centauri system. In 2013, an apparent transit of a planet was observed at Alpha Centauri b. This would not be a nice world if it exists, since it would orbit very closely to the star to the point of lava lakes on the surface. Models suggest that other planets could be in the main system, and given the similarities of these stars to the Sun and the fact that Proxima Centauri may have played a role to send cometary material towards those planets early on, potentially delivering water, means that not only are they the closest stars to us, but are among the most interesting, very much so for a future humanity spreading into the galaxy, but also remain some of the best candidates close by for the search for life right now. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently recommending some content. Fans of this channel will know that I often use artwork from noted space artist John E. Kaufman. Wonderful, amazing art, but he also recently started a YouTube channel where you will be able to watch videos of him creating that space art, and up there now is a relaxing video of him rendering a Hunamans on Ceres. Links in the description and in the end screen. Enjoy and stay safe. Be well, and be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular, in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live. The universe, if nothing else, is full of very big things. Planets can be enormous, as can star systems, galaxies, and so on. But how big do things really get in the universe? The answer is mind-blowingly huge, so here are 10 enormous cosmic structures. Number 10. The Laniakea Supercluster. One particularly interesting giant structure in the universe is interesting specifically because we're a part of it. Known as the Laniakea or local supercluster, this structure contains about 100,000 galaxies, and the Milky Way is one of them. Unfortunately, though, this supercluster is not believed to be gravitationally bound and will someday disperse. The local supercluster is immense, stretching over 500 million light years. It's actually subdivided into 4 parts, previously thought to be separate superclusters in their own right, but are now known to be linked. The Milky Way lies in the Virgo supercluster part, and it's further subdivided into a series of clusters and groupings, though we'll never know exactly how many because they lie in what is known as the zone of avoidance, which is the disk of the Milky Way that obscures anything behind it from our perspective in visible light. Also hiding in the zone of avoidance is the focus of our local supercluster, known as the Great Attractor. We can't see it in visible light, but we can see its effects and observe it in other areas of the electromagnetic spectrum. It seems likely that the Great Attractor is yet another very dense supercluster acting on everything around it gravitationally. But there is an anomaly here, or at least a potential one. Standard cosmological models suggest that the motion of galaxy clusters in respect to the cosmic microwave background radiation should be random. However, some data suggests that it's not, and that some process is causing a flow, termed dark flow, in a common direction. It's debated whether dark flow actually exists, with contradictory measurements going both ways, but there is an interesting clue here should it prove to exist. One idea is that what caused it was interactions between parts of the universe that are now beyond the observable universe, but were once very close before inflation in the Big Bang. Another possibility is that it's being caused by a sibling universe, suggesting a multiverse, or some region of spacetime that is very different from what we know and understand. Number 9. The Hyperion Proto-Supercluster. Looking deeply into space is the same as looking back in time. The further an object is, the further back in time you see it. Eventually, if you look far enough, you see back to the earliest objects in the universe. Not quite yet a supercluster from our perspective, the Hyperion Proto-Supercluster is the earliest known example. We see the structure at roughly 20% of the age of the universe, or a distance of about 11 billion light years. It's expected over time to develop into a full-blown galaxy supercluster from our perspective, though in reality it likely already is. We just won't see it for a very long time. This particular structure is also interesting because it shows a mismatch in the gravity the objects within it should have versus how it actually behaves, suggesting the involvement of dark matter. But it's dark matter interacting dating from the early universe, giving us one of the scant clues we have about dark matter, that it's been here interacting gravitationally with the universe for a very, very long time. Number 8. The Local Void. Just adjacent to our own local group of galaxies, known in this case as the local sheet, is a void, a huge one. At least 150 million light-years across, this structure's size was determined by a very isolated dwarf galaxy inside it, one of just a handful currently known to be in this void. This little galaxy is behaving strangely. It should be moving towards concentrations of matter, in other words, the galaxies at the edge of the void through gravity. And it is. But it's apparently moving too fast, invoking the involvement of dark energy in one hypothesis. To add to the mysteriousness of the void, it's also growing, with our local sheet essentially rushing away from the void's center. And to add further mystery, the local void appears overall to have fewer galaxies than standard models would suggest. Why that is unknown. What is known is that galaxies do not like to be in that void. Number 7. The Upper Limit. While not a structure in itself, what could be called the upper limit determines how large structures in the universe can be in principle. Many of the vast superstructures on this list are products of just how the aftermath of the Big Bang played out. Originally, there was very little difference in density other than slight variations in the universe. But as time marched forward, those tiny variations were amplified by the effects of gravity, forming galaxy clusters, superclusters, and the voids in between them. But there is a limit to how big those structures should be. And herein lies a mystery. Standard models in cosmology state that the expansion of the universe should limit gravity's clustering effect on objects, and that we should see a limit to the size of these structures. Problem is, there are apparent structures in the universe that exceed this limit, many of which are on this list, and some of them do it by a lot. This should not be, but apparently is. What's at play here could involve dark energy, but in a really strange way. It's usually assumed that dark energy is uniform throughout the universe. If it's not, however, and it can accumulate, then the repulsive force it exerts could push matter away, allowing for larger than expected structures. Or, alternatively, there could be something we don't know about gravity. And there's more to the story than what general relativity paints. But there's always room for error in this. Measuring distances in the cosmos is a tricky thing, and as you'll note, many of the apparent largest structures in the universe remain unconfirmed. But it's an interesting thought that if something ever is confirmed that violates our models, then we have a fundamental problem with our models of the universe. Number 6. The SSA-22 Protocluster. This structure is rather odd in just what makes it up. It's very distant, about 12 billion light-years out, meaning that we're seeing the object in a very early state. Not only are there star-forming galaxies present in the structure, but also objects known as Lyman alpha blobs. These are enormous bubbles of gas that can be so large that they measure twice the diameter of the Andromeda Galaxy. What causes these huge blobs is ultimately unknown, but it has been advanced that they are the remnants of giant supernovas that occurred among the earliest giant stars in the universe. The structure itself lines up along 3 curved filaments and is actually really dense, with all of the objects in the structure packed closely in when compared to the rest of the universe. Further study of this object will likely yield clues about how our own galaxy formed, but may also be among the first structures in the universe to have formed, yielding clues on the conditions of the early universe. Number 5. The giant GRB ring. One of astronomy's most mysterious phenomena, gamma ray bursts, seem to hint at something potentially even more mysterious. In 2015, it was discovered that a ring of 9 gamma ray bursts seemed to hint that they were in some way related. This structure, if it's really there, is amazingly distant at over 9 billion light-years away, with a diameter of 5.6 billion light-years, making it one of the largest known structures in the universe. The main question is if the gamma ray bursts are actually related or only appear that way. The distribution of gamma ray bursts in the observable universe would say that such an arrangement would be highly unlikely. If it does exist, it's likely to be a huge structure of galaxies with active star-forming regions being linked to the gamma ray bursts. Number 4. The Bhuta's Void. Also called the Great Nothing, the Bhuta's Void is an area of space about 330 million light-years in diameter. It's roughly spherical and very distant from us at about 700 million light-years away. What's noteworthy about this structure is that it's nearly empty, containing very few galaxies, at most a few thousand across the entire void. If you happen to be inside this void in one of those scant few galaxies, it would be a very strange place to exist. If you were at the center, you would need a very large telescope to even know that other galaxies existed. Just how the void came into being is an open question, but there is a good possibility that it resulted from the merger of a number of smaller voids, sort of like bubbles coalescing into larger bubbles. And indeed, there are some features of the arrangement of the galaxies that are in the void that seem to bear this out. Number 3. The CMB cold spot. This is one of those cases of a structure, at least one of sorts, that really shouldn't exist yet it does. The CMB cold spot is an enormous area of the cosmic microwave background radiation that is unusually cold, and also unusually large for what is expected from the CMB. One explanation for it is that it simply formed from quantum fluctuations during cosmological inflation. The problem is that mechanism is unlikely, though it's not impossible, to form such a large cold spot. Other options include the presence of a supervoid in space in between us and the CMB, but that supervoid would have to be enormous, perhaps the largest structure in the universe to account for it. One more controversial idea is that the cold spot is an imprint of a parallel universe that was once entangled with ours until separated by cosmic inflation. This concept is actually observationally testable, and if it ever is, then it will be the first indicator that a parallel universe to our own exists. Number 2. The huge LQG. This is a very different kind of structure, if indeed it's a structure at all. The huge LQG, or Huge Large Quasar Group, is made up of 73 quasars spread over a whopping 4 billion light-years at about 9 billion light-years from Earth. Quasars are very odd, distant and energetic active galactic nuclei, driven, it's thought, by the activities of supermassive black holes. This structure has been a subject of dispute in recent years in that it may just be illusory or an artifact of how the original study was done that discovered it, though recent work seems to suggest that it does indeed exist, and large groupings of quasars are known, just not ones quite this large. But there's a problem. There should be a limit on just how large such a clustering can be. This gets into the cosmological principle, the assumption that when looking at large scales, the universe looks the same no matter where you are. This has never been demonstrated, so it remains an assumption. An important one, since Einstein depended on it in his work, which tends to hold up quite well to observation. If the huge LQG indeed exists, then the cosmological principle is then in question. What this means for our understanding of the universe remains to be seen. Number 1. The Hercules Corona Borealis Great Wall. This structure is known not only for its immense size, if it indeed exists, but also for a link to another strange phenomena in the universe, gamma ray bursts. This enormous structure is the largest known structure in the observable universe, spanning about 10 billion light years and containing billions of galaxies. Researchers working with gamma ray bursts noticed a strange, rather implausible clustering of gamma ray bursts in one area of the sky. At first, it wasn't clear how this could be. As it turns out, the best explanation for the concentration of GRBs is that an underlying structure exists, known as the Hercules Corona Borealis Great Wall. This formation may be a region of dense star formation, thus leading to a higher incidence of gamma ray bursts, which are thought to be caused by stellar collapses and neutron star mergers. Our galaxy is also a member of a huge supercluster, but the Hercules Corona Borealis Great Wall is on the order of 30 to 50 times larger. That's thought to be improbable in this universe, leading to some question of whether this structure really exists or is a product of observational issues or some other phenomenon. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently perplexed. Life on Earth sometimes shows convergent evolution, which is why only distantly related creatures like sharks and dolphins resemble each other. Useful features are useful features, and we may well see the same kinds of forms in alien life. Feet are also useful, so aliens may have them. If those feet are rather large, then I can't rule out space Bigfoot. Very disconcerting, and be sure to check out my books at your favorite online book retailer, and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live. We live in a new golden age of conventional space exploration and travel. Through the efforts of both private and government entities constructing new launch systems and continuing the development of old ones, at no time in history has space been more accessible, even to the point of tourism. And there have been many other developments that are helping to make space more open, from the potential of CubeSats to dramatically dropping launch costs. It seems clear that we are in a second great space age, or perhaps a resurgence of the original one. It's difficult to predict the ins and outs of where this will lead over the next 50 years, but there are visions ranging from the colonization of the Moon and Mars to getting glimpses of the nearest star system to us. So here are 10 future or underdeveloped current technologies that should prove useful for space exploration and eventually colonization. Number 10. Light sails. There was a time, not that long ago in fact, where humans across the world made use of sails to harness the wind to push ships across the water. Indeed, this was once, and may someday again, be an engine of trade and economy, with thousands of vessels crossing between continents, moving goods ranging from tea to cheese, or just about anything that could be preserved long enough to make the trip, which is just about anything these days. Sailing, if a bit slow, paid off in free energy to harness. And this is also true for space. Sails in space can work. There are actually two types of sails that can be used in space. The first is the solar sail. This is a sail that uses the radiation coming off the sun to push it forward. We've already experimented with this, in the form of the Icarus spacecraft. The advantage to this method is that it requires only the sun's light pressure to move. The disadvantage is that this is a very slow form of propulsion, as a result of light pressure being very slight, but it is enough to push the spacecraft along at usable speeds. The other form can be much more powerful. It's the beam sail, and operates by a laser mounted on or in the vicinity of Earth that pushes the sail with a tightly focused laser beam. This option is behind the Breakthrough Starshot initiative, where light sails with small instrument packages could be sent to the Alpha Centauri system to explore it, conceivably within a human lifetime, and would mark the first time humans have ever been to another star system. While slow, light sails offer us the first realistic opportunity with today's technology to explore outside the solar system. Number 9. Nuclear propulsion. The idea of using nuclear energy to power rockets seems futuristic. Fusion energy is just around the corner type of thing that will never happen. And if it did, it would come with inherent dangers. But the reality is that while the latter is true, nuclear rockets have been devised, built, and tested, but never launched, going back to the original ideas regarding it in the 1940s. And it's been looked into by multiple countries and still is. While launching nuclear materials into space on chemical rockets does come with its dangers, they can be mitigated, and indeed a number of interplanetary probes launched over the years have made use of the decay of plutonium ingots for energy when solar power wasn't enough. This includes the Voyager probes, which still run to this day on the decay of plutonium far away in the outer solar system and beyond, so nuclear-powered probes, at least a form of them, have already been used. But in the end, the reason we didn't make more use of this technology in the past is that it just wasn't practical for what it was we were doing. Chemical rockets have filled the niche, and we just didn't need to pursue this avenue. But there is an advantage to using nuclear energy for space missions, and that's speed. You can get anywhere in the solar system, and conceivably another close-by star system, at much faster speeds than chemical rockets can produce. Some of the best ideas here have been concepts for a hybrid Mars mission that launches on a conventional rocket, or several and may be assembled in space, and then uses nuclear thermal rocket technology to get to Mars more rapidly than what we do conventionally. But again, there's always the question of safety and launching nuclear material into space. Materials have gotten significantly better, and it may be more safely done these days, but there's bound to be resistance to it. But once it's in space and outside of Earth's magnetosphere, it then ceases to be a problem, since space is a radioactive environment in itself. So it may well be that in the future, nuclear thermal propulsion may see its heyday. Number 8. Space elevators. The idea of a space elevator in speculative science fiction is typically one connecting Earth's surface to an orbiting station, essentially by lowering a cable and then using another cable and a counterweight to balance the system and hold it stable. This would allow the transfer of materials from the ground to the space station easily and cheaply, without the need for a rocket. In principle, this would allow for the transfer of massive amounts of materials into space that could be turned into giant space stations, O'Neill cylinders of unprecedented size, and so on. Such a system could even be built to recover much of the energy put into lifting it, as gravity pulled its carriage back down to Earth. This was the concept behind the space elevator in Arthur C. Clarke's novel The Fountains of Paradise. But there's always been a serious problem with the space elevator idea. We didn't have a suitable material in which to build one. We need far more than steel to hold this together. Now, we do have a material that can do it in principle, using carbon nanotubes or similar technology for the tether. But this material has so far proven not very easy to make. You basically have to do it atom by atom still. And even if you did get enough material for the elevator, there's always the question of calamities here on Earth, human or natural, destroying the space elevator. And that in a nutshell is why we don't have space elevators. But maybe someday, with enough development. But there is another option that may come onto the table, even if we never build one here on Earth. That is the idea of space elevators on much lower gravity bodies like the Moon or Mars. Here the conditions are different, especially in regards to lower gravity. The stationary orbits for both of these worlds are much lower due to the lower gravity, and as a result you don't need as long of a tether for a space elevator. As a result, this could be done with materials we already have. But at the same time, they'd still likely need to be manufactured on the Moon or Mars. This could look like mining the moons of Mars, or perhaps even completely to get them out of the way and for their carbon and metals, or even using Phobos as a counterweight. The Moon is even easier on the materials issue, but it doesn't rotate fast, so an elevator must use the L1 Lagrangian point to balance out the gravitational forces. If you run out a much longer tether pointing towards Earth in comparison to the other tether anchored to the Moon, this has the added benefit of not only being able to raise and lower materials to the surface, but also shortens the distance needed to travel from Earth to get to the top of the tether. Again, the problems, calamities and such, and even the very nature of where we live actually make this one of those scarce potential human technologies where Earth may never see this technology, but the Moon and Mars may. Number 7. Skyhooks. This is a sort of variation on the idea of a space elevator, though there are key differences in how they can be used. While a space elevator can be said to be a kind of skyhook, these variant ideas of skyhooks are different in that they do not anchor to a planet. The main use for the variations of the skyhook idea are to essentially gain speed for the spacecraft, without the need to carry more fuel to accelerate it out to its destination. You still need a launch vehicle, and you need faster launch systems than we use currently, but you do gain efficiency with skyhooks. The main variations being one that sits stationary in orbit of a planet, and one that rotates while it orbits the planet. Skyhooks also use the concept of a tether, where you have a cable and counterweight around a center of gravity. The spacecraft in question would dock at the bottom of the tether, essentially ride it upward like an elevator into space, reach the top and gain an advantage of increased speed. If this whole tether is rotating like a slingshot, then it can work even better and catapult a starship at even greater speeds. Experiments with tethers have been done in space, and because you're dealing with an object in space as opposed to something anchored to Earth, it's much more doable with current materials. But the trick is in docking with the bottom of the tether. Here, the tether can only get so close to Earth. If you dip it into the atmosphere, the bottom will burn up, so you have to keep it from dipping too deeply. That means that your spacecraft, wishing to gain advantage of the tether, has to rendezvous with it very fast, at very high precision, or it will miss it. That can be done. We do some very precise things in space already, but we'd need to do a significant amount of research and development on hypersonic space planes that can accomplish this. The other concern is that the tether will transfer its momentum to the spacecraft and have to be maintained to keep it at the right speed, requiring the development of advanced station keeping of a type a bit further than what we currently do, and also the capture of incoming vehicles imparting momentum to the tether. But in the end, the advantages offered by skyhooks do seem to form a niche we may use someday, especially in regards to our colonization of Mars and other places. Once again, the circumstances of Mars, should we found a colony there, would make this very useful indeed. Number 6. Railguns and mass drivers. This technology is something that isn't in the future. It's already here and has been for a very long time. The idea of moving something using electromagnetism is something we take advantage of extensively, and have since the age of electricity began. If you turn on a fan, you're using electricity to move something. This also applies to accelerating a projectile, and extensive research has been put into developing railguns to replace things like old-school chemical naval guns. There's a huge advantage to that, despite development challenges, which is safety so long as you aren't on the receiving end. There is no explosive magazine on a ship equipped with these, which was the demise of many warships throughout history. But there is a very extensive use for this technology in regards to space travel. Here the concept is typically termed a mass driver, or some variation thereof, and how you use it really depends on what you want to use it for. Firing mined metals off the surface of an asteroid is a different use than launching humans to the moon with one of these things. For humans, you have to make sure the humans inside the craft can handle the G-forces. This essentially eliminates any conventional gun, as early science fiction envisioned, rather a very long launch system, 50 kilometers or more, to gently accelerate the manned spacecraft to the speeds needed to get into space. The advantage here again is that while your construction needs to be enormous, so does a highway, so we already do things on this scale, and you save costs here. But again, the more practical use is in space, and involves transferring raw materials into space from the surfaces of worlds, especially if you need to put them into orbit from the surface of the Earth. Number 5. Space docks. One use for launching raw materials from Earth is the construction of space stations, but also spacecraft. We are limited right now in just how large of components we can send into space. To build things like the International Space Station, which required multiple launches from several countries over a period of years to build it to the size that it is, which isn't that big in comparison to what we could build in space. But building in space from materials and components launched from Earth is something we have successfully done on an international scale, and it's something we can expand on using some of the technologies mentioned on this list. One of the things this would plausibly allow for, however, is the construction of space docks and starships in orbit of enormous size, much like those envisioned in Star Trek. One thing that has hampered exploratory space missions is the dual problem of energy availability and the weight of a spacecraft along with its size. Take the James Webb Space Telescope. It had to weigh a certain limit and go no further, but it also had to fit inside of a predetermined fairing on a rocket, which played into the decision to launch it on an Ariane 5 rocket because it has one of the largest fairings out there. Even still, Webb has to operate on the total energy supplied by its solar cells, and it had to unfold itself in space in a sort of spacecraft version of origami. All of this could be eliminated if you had two things. One, better energy generation methods in space. This may come in the form of compact fusion reactors, which while they are being developed, they're not there yet. But if we get them, then we will have all the power we could possibly want for missions into space. The second is available size. There is no limit to the size of something you can build in space within reason, allowing for enormous spacecraft that could look more like moving cities in space than Voyager 2. This opens up the eventual world of generational starships that can travel to other star systems at slow speed over generations of humans, or very, very long-lived humans through life extension. It also would allow for probes of a type we can't even yet dream to build, such as giant self-replicating probes sent across the galaxy. Once the limits of being able to construct objects in space expands, so do the possibilities of what we can do. Number 4. O'Neill cylinders and giant McHenry cylinders. As with the space elevators, the biggest challenges we face is in the materials that are needed to create megastructures. They barely exist in the form of carbon nanotubes, which are very difficult to make, but offer a glimpse into a future of ultra-strong materials that make our currently very strong materials like Kevlar seem to pale in comparison. It's even possible, and some foresee this, that carbon nanotube technology might be the strongest material anyone in the universe can reasonably make, so far as known chemistry is concerned. Whether this is true or not, or if we can ever make carbon nanotube materials on an industrial scale, remains to be seen. But say for a moment that we can, and these materials are our future. This opens up a very interesting possibility above and beyond a space elevator. Rather, it allows for a true space nation in every sense of the word. Before we get to that, we have to cover the basics of a specific type of space habitat, that of the O'Neill cylinder. First envisioned by Gerard K. O'Neill, along with variations thereof. This is a habitat that produces a kind of artificial gravity through centrifugal force that in principle would allow for a somewhat Earth-like existence for anyone wishing to live in one. We could hypothetically build these now with current materials, but only up to a certain size. We can make one of very large size, but there comes a limit. But O'Neill cylinders give us a way to go beyond a mere space station, which can also be spun to simulate gravity. Rather, we can have a self-enclosed space city, perhaps sitting at a Lagrange point, or a group of said cities where people can work and live in space. And while this idea may not be too far in our future, or at least some form of it, the idea can be scaled up with the right developments and materials. And here we get into human megastructures. This variation of O'Neill's idea is called a McHenry cylinder, and through the use of carbon nanotube technology, it can be constructed in principle on a titanic scale. It too would rotate and produce artificial gravity, or rather a gravity analog, and could be built on the order of hundreds of kilometers in radius, but thousands as far as length. In fact, you could hypothetically outdo all but the very largest countries on Earth in land mass, and support hypothetically billions of people, with large-scale agriculture driven by transparent areas of the cylinder allowing sunlight in, or conceivably using solar power to provide artificial lighting. This could allow for a perfect living space, where everything is managed so well that things like crop failures, weather, though this thing would be so huge as to create its own weather that would need to be controlled, all fall to the wayside to have perhaps the ultimate instability for human civilization. There are engineering concerns for sure, many of which would need to be identified and solved while such a thing was being constructed. But in its most rudimentary form, it could be designed in counter-rotating halves that would control the station's orientation. Such a structure could persist indefinitely with maintenance and become a kind of artificial populated moon of sorts, better suited for human habitation from the start than the natural moon is. Of course, this comes with risks. Such a thing could also easily become a Death Star, its inhabitants and their emperor holding Earth hostage with their space laser as they make unreasonable demands on Earth's donut supply. Or vice versa, as we build a space laser and point it towards them every time the perfect steel ball bearing prices get a bit too high for our tastes. Such an idea, if power sources, fueling, and true self-sufficiency could ever be achieved, could even serve as the basis of a generational starship, as has been depicted in science fiction, and colonize a star system that happened to be passing nearby. You could then play with such an idea and envision a kind of camper RV park Milky Way, where cylinders of various alien cultures form settlements around suitable stars. If the neighbors prove less than tolerable, say some really radio-loud aliens next door start confounding your astronomical observations, you could use the cylinder as a sort of RV and move to the next suitable star system in hopes of finding better amenities and more peace and quiet. Or to flip it around, the alien RV cylinders see the humans coming and all vacate before we get there, leaving us forever thinking we are alone. Or at the very least, the formulation of the alien camper paradox. We should see more of these parked around, but we don't. Yet we do see them pass by on the highway with not so much as a single friendly wave. Number 3. Artificial magnetospheres. One of the major problems among many with the idea of colonizing the inner planets of the solar system is the lack of an appreciable magnetic field at both Venus and Mars. Earth's magnetic field is extremely important for maintaining the conditions of this world and its habitability. Our magnetic field protects us from the solar wind, which would otherwise strip off Earth's atmosphere, and creating a magnetosphere at Mars would be crucial for terraforming that planet if that is indeed possible. But the dynamo action of the Earth's interior that generates its magnetic field is absent at Mars, and due to Mars's interior being cooler, it's irreversible for anyone other than perhaps a supercivilization. But the creation of a natural magnetic field is neither the most practical way, nor is it even necessary. It is possible to create an artificial magnetic field for Mars, and for that matter, Venus. There are actually several ways to do it. To create a partial magnetic field, or a weak one, you can do it from orbit or the ground using magnetic field generating equipment. But a more powerful option would be to generate charged particles from the moon Phobos to create a kind of particle torus around Mars. But there may be even a more comprehensive way to do it. The idea goes like this. If you can put a magnetic field in between the Sun and Mars, that should be sufficient in getting the planet to start terraforming itself. By blocking the action of the Sun, Mars's atmosphere will start to thicken and warm. If you can do that and maintain it long term, you can potentially get Mars's atmosphere sufficiently thick as to not immediately be fatal if you were to step out of a habitat without a spacesuit. It won't be Earth, and there is some question over just how thick you can get Mars's atmosphere given recent discoveries that dropped the amount of carbon dioxide locked up at its poles, but you can start the process of making it at least a little more friendly to humans. More importantly, perhaps, is making it more friendly towards plants. More on that in a bit. Venus, on the other hand, would eventually need such a magnetic field, but its atmosphere is already thick and hot. There, the better option to start the terraforming process would be to block the light of the sun with a shield to start cooling things down. With technology that exists today, we can, in principle, already dramatically alter Venus and Mars if we were inclined to do so. Number 2. Compact fusion reactors. We often view power sources in space in the sense of Dyson swarms or spheres that can collect the entire energy of a star, or most of it, and convert it into usable energy. This makes sense in one respect. Stars produce massive amounts of free energy for the taking, but at the same time, such far future technologies may be unfeasible, from both an engineering and a cost perspective, when there is something much easier to do that can generate vast amounts of energy using the most common materials in the universe, such as hydrogen. This is, of course, fusion energy, which also happens to be what powers stars, and we're not that far from useful fusion energy for power generation, though the idea has been one marred by slow development. Even today, the biggest efforts in developing fusion involve huge facilities like ITER that wouldn't lend themselves well to being launched into space, but that's where the concept of compact fusion comes in. There are several projects afoot to develop fusion reactors that would produce on the order of 100 megawatts of energy, yet be the size of a bus, and launchable into space to build things like giant space docks and O'Neill cylinders, with no shortage of energy available. And this is one area where there could be a wild card. It's possible through the current projects looking into it that we may end up with compact fusion reactors before we have full-on large-scale fusion power plants. There is some reason to suspect that a breakthrough could happen here, and fusion energy simply appears earlier than expected, as a kind of reversal of the trend that's been going since the nuclear age began. There are no guarantees of this, of course, but the landscape of fusion energy has changed and now looks somewhat different than it did just a decade ago. We shall see. But regardless, it's probably the future. And with widespread fusion energy and plenty of hydrogen and other potential fuels in the solar system to work with, it may be that the idea of Dyson swarms on large scale never may come to fruition simply because they're not needed. This may also be why, when we look into space, we don't see any convincing evidence of those technologies, even though they should be readily detectable as technosignatures. Number 1. Genetic manipulation for space. Nothing, and I mean nothing on this planet, is truly adapted for living in space. Everything here evolved here, in this environment, and while some species such as tardigrades and certain microbes can survive in space at least for a time, it's a different thing whether they can do well and reproduce as successfully as they do here on Earth. As a result, anything we do in space that involves biology, whether it's a spacewalk or to try to grow food, almost always requires us to basically bring Earth's atmosphere with us. And to date, we also have to bring the nutrients, soil, and water to grow food. And while there are some options for growing food in the soil of Mars, it's pretty chemically hostile and would at least require washing with local water from Mars before you can grow anything. But at the same time, we can already genetically modify crops for various purposes here on Earth, and there's no reason why existing plants here on Earth can't be modified to do better in a Martian environment, at least a partly terraformed one, or in a habitat. But the idea of genetically modifying crops can be taken a step further. How about genetically modified humans? Humans, or any animal for that matter, can be genetically modified to also do better in a Martian environment. Adaptations to lower gravity, more efficient lungs, vision better suited for dimmer light, and so on can all be envisioned as better for a Martian environment, though they would often preclude any return to Earth. These genetically modified humans would truly be Martians, even though they hadn't originally evolved there. And it could also be said that a better reproduction system in an environment such as Mars might be cloning or custom genetics to ensure the best level of adaptation in such artificial circumstances. But as with anything, whether humans actually choose to do this remains to be seen. But therein is another question. If we decide to go full-on machine civilization and upload ourselves into a consciousness cloud of some sort, then we can colonize just about anything. The line between robotic and personal exploration of the solar system becomes indistinct. If one could load their mind into a robotic body, then Mars would be a simple place to explore, in the face of exploring the surface of Europa, or perhaps even skydiving in the upper atmosphere of a gas giant, and uploading oneself back into the consciousness cloud at the very last moment before the robotic body is destroyed. That would make for a very strange future indeed, especially in regards to vacations. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently worried about uplifted O'Neill cylinder agricultural crops. Think of modified corn that has an overall sense of well-being and positivity and feels great about itself. It's totally okay with being eaten, at least until a human walks by. and then everything goes off the rails as this video has at several points. So you walk past a cornfield in the O'Neill cylinder, and the normally happy corn takes on a dark flare, and every ear whispers in unison, "Memento mori, the end comes to us all," to stoically remind us humans that we are every bit as mortal as the corn. I'd say grab the butter, but then you come up against the idea of corn immortality. I think I'll just leave that one right there, and be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular, in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live. One of the greatest mysteries of the solar system is whether Mars has, or once had, microbial life. We know it was once like Earth, and it seems to hint that it could be an abode of life. So here are 10 indicators that Mars may have had, or may still have, life. Number 10. The Viking experiments. In 1976, NASA successfully launched the Viking 1 and 2 missions on the surface of Mars. One of the experiments on board the landers was the labeled Release experiment, designed to detect Martian microbial life. Essentially, the experiment exposed nutrients to the Martian environment and then looked for any evidence that something was metabolizing it. The experiment returned a positive. This detection has been problematic and controversial ever since. Part of the problem is that other experiments on the lander failed to detect organics. Another part is that the Martian surface is an extremely inhospitable environment. Problem 1 is radiation from the sun. And problem 2 are the presence of chemicals such as perchlorate, which can destroy organic compounds. This reaction would produce chloromethane and dichloromethane as byproducts, and those were apparently detected, opening up the possibility that the detection was real, and the reason that organics were not found was that they were simply destroyed. Whether the Viking landers detected life on the surface of Mars is still an open question. The only way to solve that mystery is to go to Mars and experiment some more. This will no doubt happen in the coming years as the human exploration of Mars becomes a reality. Number 9. Formaldehyde. In 2005, the European Space Agency's Mars Express orbiter detected a rather odd chemical signature in the atmosphere of Mars. It's formaldehyde. We normally think of this chemical as a constituent of embalming fluid and a carcinogen, but there's more to it than that. We see formaldehyde in the universe, and interstellar formaldehyde has been extensively studied within the Milky Way, and for good reason. It's an organic compound. In the case of formaldehyde in the atmosphere of Mars, it's possible that it could be a byproduct of the oxidation of methane. This would suggest that Mars is very geologically active, but we really don't see that it is. Its major volcanoes appear long dead, and what may still be occurring doesn't seem too active. The other option is that it's a byproduct of microbial life, but this is a pretty ambiguous indicator in the end. Number 8. The lichen that could survive on Mars. One of the best ways we have of understanding if there was or is life on Mars is to look at very resilient species of organisms here on Earth, simulate the conditions of Mars, and see if they could survive. While a number of resilient bacteria from Earth have been shown to be able to survive the conditions expected at shallow levels in the soils of Mars, one organism stood out. It was an Antarctic lichen. Known as P. chlorophanom, it survived at temperatures as low as -51 Celsius, low atmospheric pressure like that of Mars, and endured large amounts of radiation during a 34-day experiment. The lichen fared well enough that if it had some protection against radiation, such as living under a rock or in a crack, it might actually be able to survive on the surface of Mars long term in an active state, and in fact, it adapted to the conditions and ramped up photosynthesis as the experiment went on. In other experiments involving lichens, they've shown themselves not only capable of handling Mars, but clinging to life in space itself. Lichens might also survive things like Mars's global dust storms by going into a dormant state, something that some Earth lichens can do on the order of centuries if covered in snow or dust. This one has two implications. Firstly, if Mars ever developed life like this lichen, then that life could still be there, surviving in cracks or beneath rocks. Second, we should be careful with what life we transport to Mars, even accidentally, because some of it could, in principle, survive and contaminate that planet. Number 7. Oil on Mars. One of the strangest possibilities is that if Mars once had, or still has, microbial life, it may be possible that the process that produced crude oil deposits on Earth might also have occurred on Mars. On Earth, crude oil deposits are thought to be produced when marine microorganisms die and become trapped in sedimentary deposits. As this becomes sedimentary rock, heat and pressure converts the material into petroleum. While the origin of petroleum is somewhat controversial, in the case of Mars, it might have been possible for oil to form from any microorganisms that were present in the past, or, in an alternate hypothesis, trapped hydrocarbons left over from the formation of the solar system, and have crude oil deposits. In principle, these should be detectable as methane emissions, effectively natural gas, through the geologic exploration of Mars, and maybe someday an oil rig. Number 6. The reanimating corpse planet. This is more of a concept than an indicator, though if it were to happen, it would provide a perfect opportunity for observing life on Mars from here on Earth. One of the things that makes the surface of Mars inhospitable to most life as we know it is the high amount of ionizing radiation that reaches the surface. But this changes. Due to Mars's orbital eccentricity and the tilt of its axis, it may be that Mars goes through periods, the most recent being about 450,000 years ago, where dormant surface life on Mars hidden beneath the surface might reanimate and recolonize the surface for a time, a sort of periodic Frankenstein planet that reanimates periodically and resembles its former self. If this is the case, then that dormant life might still be viable and detectable as shallow as 1 meter below the surface. Future missions to Mars might look there and see what they find. Number 5. Martian geysers. Mars's southern polar cap is in a constant state of frosting and defrosting seasonally. Because of this, CO2 and likely water can pressurize beneath the surface and erupt as a geyser, usually in the form of cold fluids mixed with mud. This process happens rather quickly, even by geological standards here on Earth, which makes it very odd for sleepy Mars. Around these geysers, dark spots and channels can be seen that are not well understood. One team has proposed that they represent photosynthesizing microorganisms. The idea is that these microorganisms hibernate while the southern polar cap is in darkness. As the sunlight returns, however, light reaches the ice and the organisms beneath. As they start to photosynthesize, they produce heat and liquid water, which is trapped under the ice and cannot evaporate. The sun then further melts the ice, and the microorganisms appear gray. But as soon as the ice melts completely, they dry out and turn black, creating the dune spots. While this remains a possibility, it could also be something entirely geological that forms the dune spots. Only by going there with a probe will we answer the question definitively. Number 4. Curiosity and complex organics. In the summer of 2018, NASA's Mars Curiosity rover at Gale Crater was studying roughly 3.5 billion-year-old mudstone rocks. Within these rocks, something was seen that hadn't been seen on Mars before: large concentrations of organic chemicals, essentially the missing organics that the Viking landers had failed to detect. They came in the form of very complex organic molecules thought to have been preserved due to the presence of sulfur. Even stranger, this mix of chemicals resembles what happens when kerogens break down. Kerogens are interesting because they are of biological origin here on Earth, and in fact are a precursor to crude oil. But resembling does not make for a dead ringer, just a hint that life may have been responsible. Number 3. Fossilized bacterial mats on Mars. Life leaves its mark on planet Earth in many ways, ranging from the oxygen in our atmosphere to the fossils of shells one might find eroding from a mountainside. But even the smallest life, the bacteria, do leave traces of themselves. One such trace are fossilized bacterial mats that show the action of bacterial colonies millions of years ago. Here on Earth, these mats form in areas of shallow water, such as lakes or coastal areas. If the mats are undisturbed, they can fossilize, and in fact may represent some of the oldest fossil evidence of life on Earth, with one formation in Australia yielding examples that are as old as 3.48 billion years. But Earth is not the only place where potential fossilized bacterial mats have been seen. There are candidates on Mars photographed by NASA's Curiosity rover. Present are domes, roll-ups, pits, and other indicators in the sedimentary rock that looks much like they do here on Earth. More mats here on Earth change as they dry up, rebound, and so on. This also appears to be the case with the structures on Mars. The rocks look eerily similar. Unfortunately, to go much further with this one, we would need a sample return mission to bring samples of the sedimentary rock back to Earth to be studied in a lab. This is unlikely to happen anytime soon. Number 2. The Martian meteorites. It may surprise you, but we actually have pieces of Mars right here on Earth in the form of meteorites that originated on the surface of that planet, but were blown off into space during large impacts. There are currently over 100 known examples of meteorites that show geologic and chemical evidence indicating a Martian origin. Some of these rocks may indicate the presence of past life on Mars. This is a controversial topic, and no consensus within science has formed around just what's going on with certain features in these meteorites. At one point, it was even announced by then-President Bill Clinton that evidence of life had indeed been detected in the Allen Hills 84001 meteorite. This was called into question by other researchers, but it's an interesting factoid that the only government to have ever announced evidence of the existence of extraterrestrial life in an official capacity was the US government under the auspices of NASA, and they jumped the gun and announced it too early only for it to be called into question. Wrap your minds around that one, conspiracy theorists. The first of these meteorites is the aforementioned Allen Hills 84001. This meteorite was found in Antarctica, and in 1996 it was reported that microscopic features along with geochemical anomalies may indicate evidence for past life in this meteorite. The problem was that this life was very small, far smaller than Earth microbes, and as the story unfolded, it became clear that non-biological processes could explain all of the features seen within the rock. But life could also have been responsible, so the question to this day remains up in the air. Another example is the Nakhla meteorite, which fell in Egypt in 1911. With this meteorite, evidence of what looked like nanobacteria again were found. Further, they found organic chemicals within the meteorite that might be life-related. And they further found that most of it probably isn't recent earthly contamination, but actually from Mars. But carbon is a common element, and you don't need life for it to exist. In fact, it's the opposite in Earth's case with its carbon-based life, so no dead ringer here. Two other meteorites that show anomalies are the Shergati and Yamato 000593 meteorites. Shergati shows what appears to be alteration by water before it arrived on Earth. Fragments of this meteorite were picked up almost immediately by residents of Shergati, India, and it was an observed fall, so this is a very pristine example of a Martian meteorite. Within it, what appears to be a biofilm associated with microbes has been reported, but more work on this meteorite needs to be done before anything conclusive can be said. With Yamato 000593, this meteorite is effectively a lava rock, a basalt that formed on Mars about 1.3 billion years ago. There it sat until about 12 million years ago when it was ejected in an impact. Evidence of exposure to liquid water before it fell to Earth is present in this meteorite, but there are also bizarre spheres of carbon found inside, but only in certain parts of the rock. Biology being responsible for this is on the table, but again, it's far from conclusive evidence. Number 1. Methane. The biggest hint that something life-related may be going on at Mars is the gas methane, which is a gas that life on Earth produces. Mars's atmosphere makes methane chemically unstable. The ultraviolet radiation streaming off the sun and the chemistry of Mars's atmosphere quickly destroys the gas. This means that if methane is present on Mars, it must be replenished by some process, either geological or biological. Methane has indeed been detected on Mars. And the source of that methane is rather mysterious and tantalizing. We're not talking about a lot of methane, which was first detected on Mars in 2003. But as study continued, it became clear that the methane was concentrated in certain areas on Mars, and more provocatively appears to be seasonal. Seasonal methane releases could be produced geologically, but we also know how seasonal changes impact life here on Earth, and the lack of obvious volcanism and hydrothermal energy on Mars would be a point against geology. Bolstering this were observations from June of 2019 by the Curiosity rover, which detected unprecedented levels of methane being released. While it's still not clear if it's biological in origin, it could be that methanogenic bacteria very similar to the earliest life on Earth could still be active on Mars deep below the surface where liquid water is still possible. Once again, only human exploration is likely to answer the question. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently envisioning oil rigs on Mars. CO2 emissions will actually help Mars to warm back up, so instead of electric Mars rovers, we'll need fleets of gas-guzzling LeBarons. And later this week on Event Horizon, I will be speaking with Dr. John McGowan, who wrote the paper on the possibility of petroleum fields on Mars that he wrote back in the year 2000 while at NASA Ames. Links to the paper and the interview below. And be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live. The Fermi paradox asks the question, if there is other intelligent life in the galaxy, where are they? After all, planets capable of supporting life and civilizations are thought to have existed for billions of years before our own planet did. That's plenty of time for civilization to have arisen and colonized the entire galaxy. While it's always possible, and perhaps even likely, that civilizations are simply a lot harder to see than was thought during Fermi's day, it could also be that some great filter or filters exists that either make intelligent life very rare or preclude intelligent civilizations from existing long enough to colonize a galaxy. While there are many possible great filters, some are a bit more disconcerting than others, so here are 10 unusual and even disconcerting scenarios that could explain or even dissolve the Fermi paradox. Number 10. Life almost never becomes complex. Life on Earth appears to have had a very easy genesis. Literally as soon as microbial life could arise here, it did. From there, however, something kept it from evolving to higher forms of life for nearly 1.8 billion years. After that, complex life exploded in a flurry of evolution, but why everything paused for so long is a complete mystery. Reasons for this could include environmental factors and realities, or even biological ones. For one microbe to ingest another and incorporate it into its makeup as opposed to digesting it might be a very rare occurrence. As such, the universe may indeed be teeming with life, but it's predominantly simple life, and only rarely is it possible for it to break out and become complex. This might make Earth a fluke, and if so, you, as a member of an intelligent species, are one of the rarest phenomena that can happen in the universe. Number 9. Civilizations do not survive their atomic age. When a civilization gains the ability to destroy itself entirely, then there's always the risk that it may actually go through with it. So far, we have not, but we've come close in incidents like the Cuban Missile Crisis. In more recent years, geopolitical situations have backed away from such levels of tension, but nuclear weapons are still an elephant in the room when it comes to whether we will survive as a species long term. This is not to say we will destroy ourselves. We may make it past that point and go on to use nuclear weapons in space as tools rather than weapons. If that's the case, then the question will be answered, and that at least humans had the capacity to avoid disaster. But what of aliens? The truth is, we know absolutely nothing about them, or indeed if they even exist. But what we can say is that a technological alien civilization will know of splitting or fusing the atom. It's science that is universal across the entire universe, as evidenced by galaxies made up of stars that are themselves powered by fusion reactions. Anyone that has science will know of this, and whether they survive that knowledge remains to be seen. Whether we survive also remains to be seen. Number 8. Civilizations are out there, but have a reason not to be seen. It could be argued that once a civilization becomes a technological civilization and goes through the process of doing that, then the cat would already be out of the bag as far as being visible to other civilizations. After all, our first radio signals left Earth a century ago, and we leak radio constantly from this planet to this day. Some of it is intentionally very powerful, such as the Arecibo signal, which was done in such a way that it might easily be picked up by an alien civilization at very long distance, but only if they happen to be looking at the right time. In reality, most of the time it's actually difficult to see us. Out past a radius of about 100 light years, the radio from our civilization has not yet had time to propagate, and within that radius, any civilization that might spot us would need to be looking right at us to pick anything up. And even then, they may pick up only our most powerful radar. What they won't see are tropes, such as the Berlin Olympics broadcast, which would have been hard to pick up outside Berlin, much less light years away. Perhaps easier to detect would be indicators like the technosignature of CFCs and related chemicals in our atmosphere. These are industrial chemicals that have no source in nature, so it seems more likely that an alien civilization would detect us through spectrography rather than other methods. During the heyday of industrial production of CFCs and the corresponding ozone hole that resulted, it was not yet in the public debate that an alien civilization might be able to detect that. One must ask a question here. Do we really know enough about the universe to continue to unintentionally broadcast our existence to anyone that might be looking? For all we know, it's not wise at all. After all, in order to sneak through a lion's den, one does not cover themselves in a suit made out of steak. Rather, you tiptoe and hope. Hopefully, the universe is not like that, and the vast distances between stars severely limits interactions with any potentially dangerous civilizations. But in any event, it might make sense for anyone to mitigate the potential threat by intentionally hiding. There have been a few ways advanced recently on how to do that, such as using laser light to mask certain signatures, but thinking on that is still in its infancy. But the point is, that door swings both ways, and aliens may wish to hide their existence from us, in which case they may be there, but they simply, and perhaps prudently, hide their civilization from any prying eyes that may be lurking out there, including our own civilization. Number 7. Civilizations do not survive climate change. Given that CFCs are an artificial technosignature of an industrial civilization, or a terraforming civilization looking to warm up a planet, with that comes other industrial activities that change the makeup of planetary atmospheres. This includes things like the addition of carbon dioxide, which can warm planets. While CO2 is actually a completely natural and common gas in its own right, it can also be produced by civilizations such as our own that affect the composition of a planetary atmosphere. That changing of the chemical makeup of an atmosphere will result in climate change, both naturally and unnaturally. It's simply a property of these gases, and it can be dangerous. And while it might be also mitigated through technology and alternative energy sources, it has to be said that we cannot yet easily do that for various reasons, and may never be able to. That may also be the case for alien civilizations, and that they always go through a phase of energy production that changes their climate unnaturally, and the limits of technology never allow for a viable solution. If so, like nuclear weapons, it may be that a solution to climate change is not often found in the universe, and as a result, intelligence almost never survives for very long. Number 6. We have no idea what an advanced civilization actually looks like. The previous entry was admittedly anthropocentric, and we may well find solutions to climate change and avoid extinction from it. But what does a civilization that has passed that danger zone look like? We can speculate, but ultimately we don't know. And with questions such as what the limits of far future technologies like nanotechnology and transcending past a technological civilization to a machine civilization still unanswered, it may well be that we simply don't know what we're looking at even if we do see evidence of an exocivilization. This could have profound implications. Say that alien civilizations have science we simply haven't thought of yet, or potential means of communications that we're only just now beginning to be able to study, or it may be that being visible for a very long period of time is simply too expensive for anyone to bother, and that contact signals are instead timed to correspond with astronomical events that most in the galaxy can see, such as an impending supernova. It may be that only then, coinciding with such an occurrence, is contact attempted because everyone happens to be looking. In such a case, we could go from not knowing of any other alien civilizations in the Milky Way to knowing about tens or even hundreds in a single day. Number 5. Civilizations almost always destroy themselves in first contact warfare. There is a viewpoint, perhaps even prevalent, that aliens would necessarily be, well, better than humans. The idea is that they would have progressed beyond warfare on their world and devoted themselves to the peaceful exploration of the universe, while we humans sit here on Earth awaiting our ultimate end at our own hands. But this is by no means a guaranteed state of affairs. It could also just as easily be that we live in a ridiculously hostile universe, akin to predatory animals on a plane competing for whatever they can eat. Indeed, it takes some kind of an aggressive tendency to leave your planet at all and venture into space, even if it's done in a spirit of exploration. Passive species may simply see no need to do this. That could ultimately mean that as far as colonizing and exploring a galaxy is concerned, the more aggressive you are, for better or worse, the better. This can get even worse than the realm of the biological. How aggressive could an artificial intelligence be, or say a machine civilization far more advanced than us? Such a thing could be enlightened in some way, or it may want to convert all matter, biological or otherwise, into materials usable for its own ends. Such a thing may place no value on biology at all, seeing it as an inferior chemical process, and as such could be amongst the most aggressively dangerous things imaginable, leaving no hope that it could ever be reasoned with if encountered. And this could mean that first contact just never goes well, and that civilizations immediately go to war upon direct contact. In such a scenario, one hopes we never accidentally make first contact with an alien species. Number 4. There is no Fermi paradox because we are utterly, utterly alone. When pondering the Fermi paradox, one must make a concession that intelligent life in the universe is possible because our own existence proves this. That alone would suggest that there are others out there. But there is another possibility, that we are the ultimate in flukes, and amid all the stars and galaxies of the universe, we are, and always will be, the only incidents of intelligent life in the universe. While this seems unlikely and in some way requires human civilization to essentially be the most special thing to ever occur in the universe, an argument can be made for it. There are a number of potential filters within this idea. One is that Earth is a ridiculously rare kind of world, with just the right conditions for intelligent life to arise, from environmental conditions such as long-term climate stability, the right amount of extinction events, and the conditions needed to favor the development of intelligence, and even geologic conditions such as plate tectonics and even the presence of a large moon. Standing against this hypothesis is that Earth may not have always been the only world in the solar system with conditions such as these. Indeed, Venus may have once had oceans and plate tectonics itself, suggesting that Earth-like worlds aren't all that rare. But then you get into stellar types. It's unclear if a civilization could develop around red dwarf stars, for example, and stars larger than our Sun generally don't live long enough for a civilization to arise, as far as we know. But there are also points made that stars like orange dwarfs might actually be better than our Sun for life, at least to get started. Another related possibility is that we may simply be early in the game, and that intelligent life in the universe is rare now, but as the universe ages may become more common. Or it could also be that continued evolution on Earth will produce more intelligent civilizations as time goes on here, and providing that we're still around, we may eventually be accompanied by another intelligent species on this world, perhaps evolved dolphins or octopi. Will we go to war with them? But in the end, the sheer number of stars in the universe seems to stand against us being entirely alone. Other civilizations may be too far to detect, or may not exist at the same time we do, but odds still are that somewhere out there exists someone else. Number 3. There is no Fermi paradox because they're already here. Looking for small objects in the solar system steps a bit beyond the idea of a needle in a haystack. Finding a needle in an ocean might even be too tame. Hidden in the vast distances between objects in the solar system are any number of small asteroids, rocks, dust, and even possible alien technology. At present, we wouldn't know about it if it were there, and even in the far future, we probably would have to accidentally stumble upon it, except in a few situations. One of these might be the presence of artificial lighting on an Oort cloud object. While there is no evidence whatsoever for this, it is marginally possible that there might be someone out there, and we might be able to see their artificial lighting, even with current equipment. Or there may be zones where interstellar objects captured by Jupiter might accumulate, and by looking there, some artifact, or even just trash from an exocivilization, might at some point have been captured. Or, more ominously, it's also possible that active probes might lurk in the solar system, placed there by exocivilizations interested in studying this world, perhaps long ago wondering if someday intelligence might arise here. It's anyone's guess what a probe of this nature might do, but speculative ideas include 3D printing out custom life forms to make contact with us at some point, or exchanging cultural information with us via direct real-time communications with it. Or it may also simply watch for some technological marker that represents something that the other civilizations of the galaxy cannot tolerate, such as advanced artificial intelligence. At that point, the probe might awaken and return us to the Stone Age to prevent development of it. Number 2. Civilizations do not survive artificial intelligence. One of the major purely technological threats to the existence of our species are nuclear weapons and their proliferation. But it could easily be that as we march on through future technological advancement, they may become a secondary threat to something that could potentially be far more menacing: artificial intelligence. There are many scenarios of just what might happen if a highly advanced artificial intelligence were ever to get out of control, ranging from the proverbial paperclip maker that turns the entire galaxy into paperclips, to horrific visions of malevolent computers somehow gaining control of nuclear weapons. While it remains to be seen how likely any of these scenarios might be, the point is that this may not be a problem solely for humanity, but in fact anyone in the universe that develops AI, and it may just as easily pose a threat to any civilization in the galaxy. In short, the development of AI by anyone in the galaxy could pose a threat to everyone else, making it one of the chief threats to all life in the entire universe. The unpredictability of just what might happen if a superintelligent general AI were ever created notwithstanding, it could simply be that civilization always ends with its development, its creators going extinct at the hands of their creation. Number 1. The Immortal Galactic Dictator. This scenario is among the most chilling, and has been advanced in science fiction several times, including a variant of which forms the basis of the Mass Effect trilogy. It's the idea that within our galaxy there is someone or something that hides itself and simply prevents any other species from colonizing the galaxy, solving the Fermi paradox in that there is plenty of intelligent life. It's just being destroyed or held down by some kind of invisible galactic dictator. This could come in two general forms, either a biological or partly biological species that aggressively destroys anyone that might pose a threat to their hegemony. Another option might be a machine civilization, either formerly biological that transcended the technology, or an out-of-control artificial intelligence. This hidden dictator would have several reasons to engage in this behavior. Number 1 would be its own security. It may have been among the first, or was the first, civilization to arise in the Milky Way, and sees any up-and-comers as a threat. This may be especially so for an artificial intelligence that may have once seen the species that created it as a threat, and perhaps it caused their extinction to preserve itself. Another might be resources. If a species had every intention of surviving trillions of years into the future, there will come a time when resources for generating energy are going to become scarcer. It may see the idea of leaving the galaxy in a natural state as desirable, and is destroying other civilizations to prevent the galaxy from becoming too crowded in the old age of the universe. Such a dictator would probably be best served by hiding itself, at least until the moment of destroying unwitting civilizations is at hand. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently addressing those typing in the comments that my voice sounds a bit off. I'm under attack by microbes again. It doesn't happen often due to a strong immune system brought on by eating lots of vegetables as part of my ongoing retribution campaign against the plants for the Great Oxygenation event and subsequent mass extinction. But this time I lost the battle with the microbes. As soon as I get over this, I shall go after the microbes too with the eating of yogurt. And on that note, check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.